بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المرسلين سيدنا محمد وعلى آله وصحبه وسلم تسليما كثيرا. أعزائي إخواني أبنائي الطلبة، يتجدد بكم اللقاء مرة أخرى في محاضرة جديدة بعنوان Topography, Aberrometry and Corneal Biomechanics and More. تأتي سلسلة هذه المحاضرات في خضم سلسلة محاضرات Ophthalmology Made Easy. الجزء الأول من هذه المحاضرة سيكون فيما يتعلق بالcorneal topography and tomography. I will try to give new concepts and new principles and new ideas about the topography and tomographies, and I will avoid the basic interpretation of the topography maps, as I'm sure that all of you know about what are the basic principles of interpreting the topography map. However, I will concentrate on certain important new points that I feel, and I would like to share this knowledge with you. I hope that you will benefit from this information and you will find it useful in your daily practice. Now let's go and dive in this lecture, and I hope that you will be benefit. Bismillah ar-Rahman ar-Rahim. First of all, during this lecture, we will come across many brands and equipments and different companies. Though I would like to say that there is no any financial disclosure from this lecture, and all the information mentioned in this lecture is just for a scientific discussion without any financial disclosure. The corneal topography or tomography is broadly classified into the curvature-based topography, which is primarily measuring the curvature of the cornea, and by mathematical calculations, secondarily, it can extract some information about the shape of the cornea or the elevations. And this type of topography also divided into during the evolution of this technique into using the Placido disc without the use of the camera, like the Placido disc and the keratometry. And after they incorporate the use of camera, initially as a photokeratoscopy, then they implement the video camera and became as a video keratoscopy and topography. So topography is just a video keratoscopy that is recording the data and processing the data taken from the surface of the cornea, and processed by a video camera, and then processed by the computer to give information about the slope and the curvature. The other type is the elevation-based topography, which primarily extract the information about the elevations and the shape of the cornea, and also secondarily it will give information about the curvature and the power of the cornea. This type also is subdivided into the scanning slit-based elevation technology. That's the Orbiscan one, which is pure scanning slit based, or the Scheimpflug camera, which is like the Pentacam or Galilei. The third type is that it uses the combination of both two techniques together, which is combining the Placido's disc, that's the curvature based, along with the scanning slit like the Orbiscan 2 and Orbiscan 3, or the combining of Placido disc with the Scheimpflug like in Cirrus tomography and TMS5. So topography is mainly meant for description of the surface of the cornea. That's why curvature-based topography is a proper word for describing these types of topographies. However, for the elevation-based, because it gives more information about the anterior and posterior surface of the cornea, and with the incorporation of the Scheimpflug camera, it gives also information about the anterior segment of the eye. So the proper word is tomography rather than topography. The word topography is used mainly to describe the anterior surface of the cornea, and the anterior surface of any structure that you are describing is named as topography. And the most common example is the Placido disc based. The reason why, because the Placido disc topography is capturing the first Purkinje image that is reflected from the anterior surface of the cornea. and the posterior, the second Purkinje image that is reflected from the posterior surface of the cornea usually is dim and blurred. That's why it cannot be captured. As you can see here in this slide, this is the clear one is the first Purkinje image, and behind is the second Purkinje image, which is not clear. That's why it cannot give information about the posterior surface, so cannot give the thickness and the bachymetry. So only it gives information about the anterior segment. Similarly here, this is, for example, the first Purkinje image. The second will be blurred and small, so it cannot be captured by the system. That's why we prefer the term topography for curvature-based topography. However, the word tomography, this word initially used with the CT scan and MRI, in which we construct a two-dimensional image for a three-dimensional structure, like the brain, for example. Here, the same. We, for the eye, we construct a two-dimensional image for the whole anterior segment of the eye. So this is called tomography. Although clinically these two terms are used by doctors interchangeably, however, the proper description for curvature-based is topography, and for elevation-based and for anterior segment analyzers is to use the word tomography rather than topography. Like this slide, this is usually all these are, this is the tomography, and this is the Cassini topography for the anterior segment. The Placido disc-based topography, owing to its property on gathering information from the anterior surface of the cornea, so it is useful in studying the tear film analysis and also for contact lens fitting and in the field of orthokeratology, because it is primarily measuring the curvature of the cornea and determining the slope and the power of the cornea, and the shape of the cornea or the elevations is secondarily measured. So it is very useful in studying the tear film and in contact lens fitting, and it will provide a color-coded map display for determining the curvature and the power of the cornea. The ideal example for the pure Placido-based topography is the TMS4N and the wave light topolizer. Another type of corneal topographer, which is known as the LED reflection topographer, that's the Cassini corneal topographer. It is unlike the Placido disc-based corneal topographers, as it is containing what's called septimal ball that projects a series of colored LED lights that this light get pictured on the cornea, and the device will analyze the reflection from this LED lights by the process of ray tracing, not by reflection, ordinary reflection as a Placido disc. And these multiple spots with very high precisions in microns. So it gives very good information about the anterior surface of the cornea. Moreover, the manufacturer claimed that the central 3 mm is a real objective data, unlike in the Placido disc where the this area is extrapolated because of the presence of the central camera, so that in Cassini the central area is well represented in the Cassini topographer. And another thing that the presence of this 7 white spots, this is picturing the second Purkinje image. You know, the initial spots, they are focused in the first Purkinje image, so it reflects the surface of the cornea. However, the other LED spots are for targeting the second Purkinje image, so we will have an idea about the posterior surface of the cornea. So we then we will have a good estimation of the bachymetry, as well as also having a good idea about the corneal astigmatism, taking in consideration the anterior corneal astigmatism as well as the posterior corneal astigmatism. So this is a new emerging technology and still promising. It's used mainly now in the determination of the astigmatism and determination of toric IOL calculation for cataract surgery. So this is another type of topography that is based on LED reflection, based on ray tracing using a LED lights. Now I would like to speak about some of the limitations of the Placidus disc topography, purely Placidus disc based, is that the alignment, when the line of sight is not properly aligned with the topography, so this is a major source of error. As you can see here, when the eye is aligned with the topography, it gives you, for example, this is asymmetric poti. However, when the eye is misaligned, or you have variations of angle of kappa, so it gives you a false impression that this is a keratoconus. Especially this is true for the axial map. That's why we said in previous slides that to rely on the to determine the shape of the apex of the cornea and the shape of the cone, better to rely on the elevation map rather than the axial map. The other main source of error or limitation is the tear film quality. If you have a poor tear film quality, there will be some missing data. As you can see here, the Myers will not be represented or projected properly in the surface of the cornea, and the missing data will be extrapolated by the machine, and this is also another source of error. Such cases, you have to manage the tear film instability first by giving the patient some lubricants, and then you take another picture after a few days. So this is another limitation. The third limitation, that the Placidus disc mainly is accurate in the central part of the cornea, because the central part of the cornea is spherical in shape. However, the periphery, as it is flatter, the data is not that accurate, and the distance between the Myers will not be properly reflecting the real curvature of the cornea. So extraction of the data from the central part is more accurate than the peripheral part of the cornea. Another thing, that in the very center of the machine, there is a camera that captures these Myers. So in the very center of the cornea, there is a missing data, act as a blind spot, similar to the blind spot in the visual field. So there is also some missing data in the very center of the cornea. These are the three major drawbacks or limitations of the Placidus disc. Apart from that, the Placidus disc only concentrates on the anterior surface of the cornea. So this is like an iceberg, that the posterior surface and the data in the posterior surface are missing, and also the data regarding the thickness of the cornea is missing. So it just only gives information about the anterior surface of the data. This is make the elevation-based topography has a superior advantage over the Placidus disc topography. After finishing speaking about the curvature-based topography, now the time is for the elevation-based topography. We will speak a few words about the elevation-based topography, especially the scanning slit and the Scheimpflug-based camera, and we will show the difference between these two systems. The third type of corneal topography, which is properly should be named as tomography, is the elevation-based or projection-based tomography. As I said, this based on the detection of the elevations on the surface of the cornea. So it gives more information about the anterior and posterior surface of the cornea and the thickness of the cornea, and beyond the cornea, it can extend up to the anterior surface of the iris and anterior surface of the lens and posterior surface of the lens. So it is like an anterior segment analyzer. So the new machines, they incorporate both the curvature based along with the elevation based or projection based, so that they have more detailed information and real representation of the surface of the cornea, as well as the posterior surface and beyond the posterior surface of the cornea. The two types of the elevation-based devices is the Orbiscan, that's made by Bausch & Lomb company, and its family. I will explain the progression later on about the Orbiscan, from Orbiscan 1, 2, 3,
and then the Pentacam. Both they are using different principles. The Orbiscan using a scanning slit technology, and the Pentacam using the chain flow technology, and the Galilei uses a two chain flow camera.
For scanning slit-based tomography, the most popular that from the Bausch and Lomb, that's the Orbiscan, and it has different upgrade and different generations. Orbiscan, based on this scanning slit technology, that it projects a scanning slit beam for 45 degrees angle over the right and left side of the cornea, as you can see here. And both of these rays will be overlapping here in the center, so gathering more information on the surface of the cornea as well as onto the back surface of the cornea. So this is the initial generation. This the Orbiscan was just only a scanning slit beam. Then they upgraded to the Orbiscan 2, in which they integrate the Placido disc along with the scanning slit. So a more detailed information on the anterior surface and posterior surface along with bachymetry is achieved. After that, they incorporate the Xioptics Aberrometer. So they make the Orbiscan 2Z, and it was useful to integrate the Aberrometer along with the Orbiscan for customized ablations during LASIK. Now the current generation available is the Orbiscan 3, which is represent the third generation of the topographies, and it incorporate a advanced Placido disc system along with the scanning slit and even the biomechanics. They include the biomechanics study along with this topography.
The Orbiscan 2 is the successor of the Orbiscan 1 because it combines both the Placido disc as well as the scanning slit. Now, the Placido's disc, based on the principle of specular reflections, that is, the incident rays they have and the reflected rays, they have the same angle and is reflected from the anterior surface of the cornea. Hence, it has a good information about the curvature. And also, the scanning slit will detect the backscattered rays from both the anterior and posterior surface of the cornea. Hence, it has more information about the posterior surface of the cornea, and in turn, it will give information about the thickness of the cornea. Combining these two mechanisms together will yield very good detailed information, usually by throwing a 20 scanning slits from each side, from temporal to the central part of the cornea. Total 40 scanning slits will complete the whole cornea from the limbus to limbus, and the central area will be overlapping so that more information on the central area of the cornea. So by this way, this is the mechanism of the Orbiscan 2. I have good experience with Orbiscan 2 as it was available in the Tripoli Medical Center over the last 10 years. It has done a very good job, but it has some drawbacks and some limitations in compared to the new generations of tomographies that's available currently in the market. Number one, it has a little bit longer processing data, and the acquisition time for the image is long because it has to take both the Placido disc image as well as the scanning slit, so that some patients might be not cooperative, and also the image might be truncated by the blink of the patients. And since also purely dependent on the Placido's disc, so the abnormalities of the tear film will induce some artifacts in the image capture. The other thing that is in complicated cases like post-refractive ectasia or advanced keratoconus, also it have some limitations. However, during that time, Orbiscan 2 was the gold standard for studying the anterior and posterior segment of the cornea.
The Orbiscan 3 now is currently available, which is the successor of Orbiscan 2. As you know that Orbiscan 1 and 2 now are obsolete. So what's available now is the Orbiscan 3, and it combines both the scanning slit principle along with the Placido disc. So it belongs to the third generations of the anterior segment analyzers from Bausch and Lomb, and it provides information about the anterior and posterior surface of the cornea, along with all the accessory information like the pachymetry and the anterior and posterior surface astigmatism and all the details. Also in this brand, also they incorporate the study of the biomechanics along with the topography and tomography study. However, it is not that much famous and popular within doctors in believing that the scanning slit technology is not as accurate as the shame flock technology that's present in the pentacams and all the tomography systems that are based on shame flock. And even there are some studies showing that the scanning slit technology is not that accurate as shame flock. However, other studies showed that the interchange of the information between different systems is not applicable and is not reproducible. So you cannot comment in the pachymetry map from, for example, from Orbiscan 3 and compare it with the pachymetry map from Pentacam. This comparison is not valid. However, Orbiscan 3, I mentioned it here just to complete the view and the follow the evolution of the scanning slit technology, but it is not as popular as the shame flock technology.
The corneal topography or tomography are classified mainly based on the mechanism of image processing and the acquisition of the image from the cornea as a reflection-based tomography or topography and a projection-based topography. The reflection-based topography based on the principle of throwing an circular mirrors, concentric circular mirrors on the surface of the cornea, and the reflected back rays are captured and processed by special computer, and the processing will determine the distance and the distortion between these mirrors, and accordingly it can calculate the slope and the radius of curvatures, and in turn it will give information about the power of the cornea. So the reflection-based corneal topographies mainly gather information based on the first Purkinje image on the surface of the cornea. So it gives detailed information about the curvature and the power of the cornea primarily, without much information about the posterior surface of the cornea and no much information about the corneal thickness or pachymetry. However, the projection-based corneal topography with its two main subdivisions, that's the scanning slit type or the shame flock type. Primarily, it measures the elevations on the surface of the cornea, and hence it gives a good information about the shape of the cornea, and also can extend the data extraction to reach to the posterior surface of the cornea and to the anterior surface of the lens and up to the posterior surface of the lens. So a spectrum of large informations is gathered using the projection-based topography, including the curvature as well as the power of the cornea and the thickness of the cornea and the anterior segment analysis and the surface of the lens and up to the posterior surface of the lens, and even extend the spectrum to involve the angle and the iris, the contour of the iris. So the recent topography or tomography machines combine these two technologies together to utilize the maximum benefits of these two technology. Utilizes the benefits of the reflection-based from the anterior surface of the cornea, and also the advantage of the projection based on the posterior surface of the cornea and beyond the posterior surface of the cornea. So in the coming slides, we will give the example of the different types of these technologies and also emphasize on the advantage and the difference between each one.
Now the time came for the last type of corneal topographies, the elevation-based, which is the Schoenflug-based corneal tomographies. And now this type of tomography is having the trend in the field of corneal imaging. And the most common is the pentacam and the Galilei line. We will speak a few words about this system.
The second type of the projection-based or elevation-based tomography is the Schoenflug technology, using the Schoenflug technology. The typical example is the pentacam. In this technology, the principle of the Schoenflug imaging, based on the principle that the film plan or the sensory plan and the camera plan and the intersection plan of the eye, they are not coaxial with each other, but they are tilted in such a way that the plan will meet in a point, the intersection point, so that the proper focus will be in the cornea and increase the depth focus in the cornea, so that more detailed information will be captured from the cornea. Around more than 25,000 points can be studied in the cornea over 2 seconds. You will see in the next slide that in the traditional camera, both the camera and the sensory plan and the eye plan are coaxial to each other, so that can focus only particular points which are in focus. However, by tilting the lens plan so that they meet in a single point here along with the plan of the eye, so that more detailed information on all points at the same time, and while the camera is moving and rotating, it will gather around 25,000 points in the cornea within 2 seconds. All these data are processed by a process known as triangulations, and will be displayed or transmitted to a computer system that will display them in a special map known as the quad map, and all the informations regarding the anterior surface, the posterior surface of the cornea, as well as the anterior segment of the eye will be studied in details.
The modern topography based on the Schoenflug principle or technique is known as tomography. Why tomography? Because it is giving a picture beyond the topographic surface of the eye. So it is an optical sectioning that gives detailed information on the anterior segment from the anterior surface of the cornea up to the posterior surface of the lens, and even the angles and the anterior surface of the iris. So it is giving detailed information beyond the surface of the cornea, so it is called tomography. And as I explained before, this principle and the high speed of the Schoenflug camera can capture the backscattered rays and gives a high three-dimensional image of the anterior segment, and gives increased depth of focus of the image captured, and enable detailed assessment of the corneal curvature and the corneal elevations. The rotation of this high-speed camera around 360 degrees with a high speed, about 50 sectional images within 2 seconds. More than 4,000 pictures can be taken for the anterior segment. This is example of 2 images, one taken by a normal traditional camera and one taken by the Schoenflug camera. As I said, that the traditional camera, the picture and the sensor and the camera should be coaxial, so that you have a particular focus in one point and the other points will be defocused. For example, in this picture, you can see the seashore is well focused. However, the peripheral parts of the image, like this area, is defocused. However, by using the Schoenflug camera, you can have an increased depth of focus, and the quality of the image will be much better. And you can have a very large depth of focus, so that the area of the seashore is in focus, and also the peripheral part of the image also is in focus. So this is the principle or the main advantage of the Schoenflug camera as compared to the normal camera. This picture shows the different commercially available tomography systems available in the market. Of course, the most common one is the pentacam, which is present since long time, and actually a pentacam now is a family of pentacam that ranges from the classical pentacam to the HR pentacam to the axial pentacam for the optical biometry, and then lastly they developed the wave pentacam act as a barometer using also the Shanflock technology, and with the extra features of the objective refraction and also retroillumination, which make it very peculiar to the pentacam system. So pentacam is the new trend now since 2002 till now, is the most common Shanflock available tomography available in the market. However, there are other systems which are using the same principles and even sometimes gives a high resolution as compared to the pentacam. For example, the Cyrus system is a combination of both the Shanflock camera along with the Placidus disc, and it can provide up to 21,632 points examination, because it's combining both the Shanflock and the Placidus disc. The Galilei is using two Shanflock camera and using can examine up to 122,000 points in the cornea. However, the pentacam using one Shanflock camera and can examine 25,000 points in the camera in the surface of the cornea. So this is the most popular and common Shanflock systems. And among the difference from the Placidus disc, an important point is the Shanflock system is independent of the angle of kappa and also is independent of the corneal tear film. And this make it very important and avoid the artifact of the tear film that usually seen in the Placido disc based, and also in the positioning of the eye when there is variations of angle of kappa. As we will see later when we discuss about the axial maps, we will see that in Placido's disc based axial maps, the variation of the angle of kappa can lead to changes and the shape of the appearance of the cornea, and can lead to a false positive result or interpretation of keratoconus. Another thing, now the Shanflock cameras or the pentacam extend its range from the cornea beyond the cornea and also to image the sclera, and gives a total morphology of the anterior segment of the eye, and that will be suitable for contact lens fitting and those with the scleral contact lens, and for orthokeratology as well. So it gives even information about the scleral profile as well. So pentacam is a huge multimodal system that gives a detailed information about the cornea, and it becomes the gold standard in any refractive surgery, and also it has been since long time the gold standard also in the glaucoma management, as it gives a detailed information about the anterior segment and the relation between the iris and the cornea. One of the disadvantages of the presence of different modalities of tomographies or topographies in the market, that the data cannot be interchanged between different systems, in terms that if you have a baseline study for one patient, for example keratoconus, and in the following visits or next visit, and you want to document progression, or after you have conducted a cross-linking, you want to document the rest of the disease, and that the disease becomes under control, you cannot, for example, use a baseline study from Orbiscan, and then in the next visit you use another study with pentacam and so on. This is one of the drawback and the disadvantage, that the data information is not interchangeable. And this is really is not just a problem in the topography, but it is a problem in all the systems available in the market, and the huge evolution in the technology. For example, the same thing in the perimetry, you cannot interchange the data between, for example, octopus perimetry and Humphrey perimetry, and you cannot transfer the data from, for example, the OCT from NIDIC system and TOPCon system and so on. So this make the evolution of the or the introduction of artificial intelligence in the field of ophthalmology. One of the aim of this technology is to make unifying system that can collect data from different sources and interpret them by the process of machine learning or deep learning, and then it will display these informations and help in the early detection and the diagnosis of the condition regardless of the source of the data or the informations. So you will have a central receiver system that receive the informations from different systems and underwent processing and deep learning, so that it will aid the doctors in the diagnosis and the detection and the progression of the disease. This is one of the aim of the artificial intelligence, which is still a revolution in evolution. After this brief introduction about the basic principle and differences between the different types of topography and tomography, I just like it to give very quick notes on certain important points on the different maps of the topography, the curvature map, either axial or the tangential map, also in the elevation maps and the thickness profile. I will speak about the special map, which is recently added to the Pentacam, which is the bad display, and also about the thickness profile and the spatial profile of the cornea. The aim of this presentation is not to provide the basics of the reading of the topography map. I presume that all of you know the basics, but I just like it to emphasize and highlight on certain important points that is, I feel it is new and should be added to your knowledge for improvement in your understanding of the topography. I will start with the curvature map, and then we'll progress to the other maps. As I said earlier, that the aim of this lecture is not to go through the details, basic reading of the topography map. As you can see, there are a lot of points that you need to look and go through in the topography map. We will not go through all these points, but I will stress in certain important points that I feel I need to speak about them, just to refresh your knowledge with the update and the understanding of topography maps, like the bad display of the Bellon-Ambrosso and the bad display scoring system, and some perils or some points that I feel them important in understanding the topography. Understand that topography, ABC, stands for anterior surface, posterior surface, and corneal thickness. So this is like the emergency aids that you will do when you find a patient at rescue. So even topography, you need to have an ABC lock to these maps before you give any diagnosis. The next presentations will speak about the different types of the curvature maps, and a special emphasis on the axial map and the tangential map, as they are the main common maps for the curvature maps. Also, I will come across some of the special maps that they have special uses, but they are not commonly present in the quad map or in the main display of the curvature maps, like the refractive power maps and the true net power maps and the equivalent keratometry map, EKR map, or the total corneal refractive maps. The first map and the first famous map in the tomography or topography display is known as the anterior sagittal map, and is famous by the name of the axial map. And this axial map is mainly represent the dioptric power from the anterior surface of the cornea, based on the Snell's law. By the power of the cornea is in direct relation with the refractive index of the anterior surface of the cornea, along with the radius of curvature of the anterior surface of the cornea. And this map denoted by the color scale, that hot colors represent steep meridians, and cold color represent flat meridians, and the center in the crosshair in the center represent the anatomical center of the cornea. And always we extract the data from the central 5 millimeter zone, avoiding extracting data from the periphery. And the reason for this I will explain in the next slide, especially when determining the location or the apex of the cone. The axial map is not very well precise in determining the location of the apex of the cone as compared to the elevation map. The elevation map more accurate in determining the exact shape and location of the apex of the cone. However, this map is very important to give information about the curvature and the power of the cornea from the anterior surface. And always extract the information from the central 5 millimeter zone. Avoid extracting any information from the periphery, because in the periphery it is not accurate. And the reason for that, that the axial map assumes that the eye is a sphere. So it measures the curvature of each point of the cornea in relation to the optical center or the visual axis. So that if we want to measure the power of this part of the cornea, it draws the system, the computer draws a circle and take the radius of this circle, so that the power of that part of the cornea is corresponding to the radius of curvature of the circle. Similarly, if you want to take any other points in the cornea, the same thing. So they will utilize the same visual axis as a reference, so that the radius of curvature is measured, and accordingly we determine the power of that point. Of course, this is true for the central part of the cornea, because the central part of the cornea is spherical. However, the peripheral part of the cornea is prolate in shape or flatter. So this is not accurate in the periphery. It is not that accurate. So that one of the disadvantages of the axial map, it's accurate in the central part but not accurate in the peripheral part. But it is famous and commonly preferred by doctors to use this axial map, because it gives a general overview information about the power of the cornea, especially in the central part of the cornea, as if that you are looking to the eye from a high distance. If you are looking to the eye from a very high distance, so that a general information about the shape of that eye is given by this axial map. A normal cornea can be the form of regular shape or oval. Regular shape, usually like spherical shape like this, with no much changes in the curvature from the center to the periphery. And it might be as oval in shape with very mild degree of astigmatism, or if it has significant astigmatism but within normal range, it is take the shape of bow tie. And this bow tie is usually orthogonal shape with the rule astigmatism, with the symmetry in the two parts or the segments of the bow tie without truncation or without skewed deviation. This is the normal cornea. This is the normal regular cornea. Also, usually there is symmetry between superior and inferior. The difference between the power between superior and inferior is not more than 2.5 diopters, and from the inferior to the superior, not more than 1.5 diopters. The normal shape of the cornea in the curvature map or the axial map shows high degree of symmetry across the horizontal midline, as you can see here, the typical appearance of the symmetric bow tie, and also shows a homogeneous uniform distribution of the power of the cornea. As you know, the normal cornea can be spherical, or it can be with mild degree of astigmatism. So it can see a mild degree with the rule astigmatism gives the symmetric bow tie appearance. And the normal power distribution of the cornea falls within 42 to 44 diopters. Usually take the yellow or the green color. The other steep parts of the cornea will have a red color, and the flat part will have a blue color. Another thing is normally there is a mirror image of the shape of the two eyes, right and left, as you can see here. This is known as enantiomorphism. endomorphism. So this is the normal appearance of the eye using the axial map. In the next slides, we will show the appearance of the abnormal shapes or abnormal astigmatism of the or irregularity of the surface of the cornea, how they appear on the axial map. Another thing about the axial map that gives you a general overview about the astigmatism. For example, when you look to the Myers here and the orthogonal lines of the steep and the flat meridians, so you can see that this is a regular cornea and there is no much irregularity after excluding the peripheral part. So what's important for me is the central 5 millimeter zone. So this is orthogonal and regular astigmatism with the rule astigmatism. Another thing, all doctors prefer to look to this map to determine the pattern of the astigmatism in the form of the bow tie and determine the shape of the bow tie. For example, this is symmetric bow tie. This is symmetric bow tie with radial X skewing, and so on. But for example, this is also a symmetric bow tie with inferior steepening. So having information about the shape of the pattern of the astigmatism is preferably to be used the axial map. This is also the shape of the clawing or crepe claw appearance or the kissing pigeons of the pellucid marginal degenerations. As I said, however, this is, for example, the apex of the cone. But as I said before, that to determine the exact location and the shape of the apex of the cone, better to rely on the elevation map rather than the axial map. Another limitation of the axial map that it is subjected to bias and errors due to poor alignment and poor fixation. So in these maps, you should make sure that the quality specification of your image is very good and there is no much extrapolated data, especially in the periphery. And also proper fixation of the patient is very important, so that to avoid the artifact due to misalignment, because if there is any deviation, it will give you a false positive appearance of keratoconus or any abnormalities. This is very peculiar to the axial map. I'll speak about the limitation of the axial map. Among the limitation of the axial map, that it doesn't describe the shape properly. It describes the curvature, and the shape is better described by the elevation map. Now, previously they did the test on the astigmatic test object, and they variate the angulation of the eye by variation of the angle of kappa. So it gives the same picture for the patient with different angles of kappa. So they say that the variation of angle of kappa does not change the shape of the cornea, which is not true, because the normal cornea is not a stigmatic structure. It is a spheric stigmatic structure. And when they repeat the same test onto the spheric astigmatic structure like this, you can see that the cornea have different shapes, and you will have the impression here that this is astigmatic bow tie with inferior steepening. So you will have a hint that this is a case of keratoconus. But actually this is not true, because these patients, they have completely normal cornea. What they have is what's known as displaced apex of the cornea. When you look to this patient, this is the axial map after proper centration of the eye. And normal bachymetry map, and the posterior flotation map also is completely normal. And this is also the anterior elevation map, is normal. What appear as if the apex of this cornea is a little bit displaced down. Is a little bit displaced down. He has a large angle of kappa, but it gives you the impression that there is as if there is inferior steepening here. So what I want to tell you that always when you want to have an idea about the shape or the apex of the cornea, look to the elevation map first before you look to the curvature map, and you should take in consideration all other parameters like the angle of kappa and the bachymetry and the thickness of the cornea. All this together will gives you a clue about the presence or absence of keratoconus. But if you depend only on the curvature map, you will be
misled, and you will have a false positive diagnosis of keratoconus. So elevation map describes the shape of the cornea better than the curvature maps.
As I said earlier, that the axial map is used and preferred by doctors to determine the pattern of corneal irregularity and the type of astigmatism. So based on Rabinovich classifications or the different types of the corneal patterns divided into different groups, symmetric group and the asymmetric group, like the superior steepening or asymmetric botai with superior steepening, inferior steepening, and symmetric botai with inferior steepening. Also, there is another group which is the angulated group where there is skewed radial X deviation with or without symmetric botai. And the last group, which is the special forms of irregularities like the clawing and the vertical D and so on. Now, without going to the details, as I said from my introduction to this lecture, that I will not go to the details of studying the details of the different maps and the cutoff values for each finding, including, for example, the radial X deviations and the steep and flat meridian and so on. I just give an overview generally, and the details are present and available in any source you can follow. What I would like to highlight the importance of the axial map in determining the power of the cornea and the curvature and determine the pattern of astigmatism. After knowing the normal shape of the cornea, how they appear in the axial map, now let's come to some of the topographic signs of a regular cornea. Keeping in mind that irregular cornea not necessarily means ectatic cornea. There are many causes that gives you the appearance of a regular cornea, like the presence of tear film abnormalities, also the lens warpage syndrome, that's due to prolonged use of the contact lenses, also the corneal degenerations. So there are many causes of irregular cornea, not necessarily to be an ectatic corneas. And the pattern of irregularity can take the two forms, either changes in the power or the steepness of the cornea, or into the changes in the pattern of the cornea. So the powers in the form of either superior steepening of the cornea or inferior steepening of the cornea or focal steepening of the cornea. Now, as I said before, that there is a homogeneity between the two halves of the cornea across the horizontal midlines. However, this homogeneity, if getting disturbed so that the inferior cornea is more steeper than the superior cornea by more than 1.5 diopter, this is more suspicious. Or if the superior cornea is more steeper than the inferior, also this is more suspicious. Also, the focal steepening of the cornea, which is known as the hotspot syndrome, in which you find high degree of steepening in the center of a regular cornea. Like this, you have a regular cornea with a spot of high power in the center. This is also very suspicious. Now, for the abnormality or changes in the pattern of the cornea, as we said that the cornea can be oval or round, there are different patterns of the astigmatism that can be seen in the form of symmetric botai, asymmetric botai, or symmetric botai with a skewed deviation, unlike this. The importance for us is, for example, one of them is the against the rule astigmatism. Now, sorry. The against the rule astigmatism, if it is present within the normal range and with symmetric botai, this is acceptable. However, if you find a high degree of against the rule astigmatism with saddling of the two bars of the symmetric botai, this is more suspicious and should be taken seriously. If you find a high bar with a skewed deviation like this, this is very significant. Another thing is the what's called symmetric botai with radial X deviation. I mean radial X deviation. This is called the lazy 8 pattern, which you find this is the angulation. You find the two segments of the symmetric bow tie are not orthogonal, and one of them is skewed. If the angle more than 21 diopter, this is significant, like this you can see in this image. And if it is associated with difference of more than 1.5 diopter, this is typical of keratoconus, and this is called lazy 8 pattern. So against the rule of astigmatism, and skewed radial axis deviation also is very important abnormal patterns. The other thing is the truncated symmetric bow tie. Truncated means short, means very high power in the center. You find symmetric nipple cones, for example, and you find a very high astigmatism in the center, and symmetric bow tie with very high power. This is called truncated symmetric bow tie. Also, this is suggestive of abnormal cornea and may suggest of keratoconus. Another some pathognomonic features like the crepe claw pattern. The crepe claw pattern, this is in which you find a very large inferior steepening of the cornea, reaching up to the far periphery of the cornea, leaving very small area of normal cornea. And it looks like an inverted C pattern sitting on its back, like a C pattern sitting on its back, or also called as kissing pigeon. Now, this appearance may be suggestive of pellucid marginal degenerations, or sometimes in a pellucid-like keratoconus. How we differentiate between pellucid marginal degeneration and pellucid-like keratoconus is by looking to the Biomechanics map. In the Biomechanics map for a pellucid marginal degeneration, characteristically has what's known as the pill sign. This is the shape of the pill, and this is the opening of the pill. This is typical pill sign. This is suggestive of pellucid marginal degeneration. However, in keratoconus-like or keratoconus-like pellucid marginal degeneration, usually there is no pill sign. So this is the common abnormal signs, topographic signs of irregular corneas in the form of the power or the shape of the cornea. The second most common curvature map after the axial map is the anterior tangential map, also known as the instantaneous map or the local map. Why it is called the local map or the instantaneous map? Because it gives a more detailed information on each and every point in the cornea. I will explain it how this happens, and that's why the map appears noisy and full of information and gives you a more detailed information about each and every point of the cornea. And because it does not undergo peripheral smoothing as it happens in the axial map. I explained earlier that the axial map is more accurate in the center and less accurate in the periphery, because it assumes that the eye as a sphere, which is not true, because the peripheral part of the cornea is flat. So the flat information, the flat part or the peripheral part of the cornea undergo some smoothing. However, the tangential map, it doesn't undergo smoothing. So that's why the K reading appears a little bit higher as compared to the axial map. And in the standard IOL calculation, they don't use the K reading from the tangential map for this reason. But the tangential map is very useful in describing the irregularities of the corneas, and also to have a detailed idea about the astigmatism and the pattern of coning and the morphology, and determining the type of cone as nipple cone or oval cone. So this is the advantage of the tangential map that over the axial map. So it is very sensitive to any local irregularities in the surface of the cornea. That's why it gives more detailed informations. Another point that how we measure the power using the tangential map is that it doesn't rely only on the visual axe to measure the radius of curvature of each point of the cornea, but each point in the cornea, it draws a circle like this, and from this circle, it measures the radius of curvature of each point in the cornea. So it respects the irregularities on each surface of the cornea. So you will have multiple powers and multiple radii, not just only one radius of curvature as happens in the axial map. That's why this map becomes noisy. That's a lot of information, but are more precise and more important. Now, this map looks like that you are looking to the cornea from the ground, that you are in front of the patient and you're looking to the cornea. So it gives you a detailed magnifying view of the cornea. Unlike the axial map, as I said earlier, that as if you are looking to the cornea from far distance. So you will have a general overview of the cornea, but no details. But this one, as if you have made a zoom in the cornea and you have more details about the irregularities of the cornea. After finishing the axial map and the tangential map, now we will come across the special power maps. These power maps, they have a specific application. They are not commonly used for IOL calculations except for the effective keratometric reading. However, they have certain applications. We will come across them now. There are other special maps that they are not that famous as the axial and the sagittal map, and they have certain uses in certain situation in which they need to measure the real power of the anterior surface of the cornea or for after surgical interventions. One of them is the refractive power map, which gives the real power of the anterior surface of the cornea based on the real refractive index of the cornea. That's 1.37. And that's why it is not used in the IOL calculation, because it will gives over estimation of the power of the intraocular lens. And it is used in determining the spherical aberrations along with the tangential map. So it is not used in the IOL calculation, but used to have more information about the cornea as far as the spherical aberrations, and to know the real power of the anterior surface of the cornea using the real refractive index, not the assumption that has been made before that the anterior surface of the cornea has a refractive index of 1.337. This is another special power map. Also, this is the true net power map, which also it uses the true refractive index of the cornea, not the assumption that's made for the refractive index. And it measures both the anterior and the posterior surface of the cornea. So it gives the true net power of the cornea. And also it cannot be used in the IOL calculation because it is using the true refractive index, not the keratometric index. The keratometric index that's used for the central 3 millimeter uses assumption of the refractive index, but this uses the real value of the refractive index for both, for the anterior and posterior surface of the cornea, and it applies the Snellen's law for the calculation of the power of the cornea. Now I would like to speak about important term. You will find it in the report of the Pentacam, especially in the holiday report. That's the effective K reading. Now, what's the meaning of the effective K reading and what's its applications? The effective K reading is the one which should be used in patients who underwent keratorefractive procedures, so that standard K reading using the SIM-K or the sagittal K or axial K is not valid anymore to measure the intraocular lens power, because the changes in the curvature and the refractive index of the cornea. So by effective K reading, we mean that we have a corrected K reading for the errors made by that surgical interventions, so that this K reading is the most likely accurate K reading that should be used in that calculation. Another thing, by the use of the K reading, you don't need to use any A constant for any particular type of intraocular lenses. And I will explain later what's the meaning of 65, but this is the main applications of the K reading and the meaning of the effective K reading. Now, how it is calculated by the machine itself, that it assumes the net power of the cornea by calculating the power of the anterior surface and the posterior surface of the cornea, taking on consideration the Snell's law based on the radius of curvature of the anterior and posterior surface of the cornea, and the refractive index of the anterior surface and posterior surface of the cornea. This is the real refractive index of the anterior surface, that's 1.376, and this is the refractive index of the posterior surface of the cornea, 1.33, because the posterior surface is facing the aqueous and the anterior surface is facing the air. Now, after calculating the net power of the cornea, it again recalculates the power of the posterior surface of the cornea based on the assumption that the refractive index is 1.3375, and based on the assumption that the back surface of the cornea is 82% of the anterior surface of the cornea. And by special calculation, it adds this error to the net power again, and it comes with the effective K reading. Now, so it is a little bit complicated, but what you need to know is that the effective K reading is a corrected K reading for the assumption that the refractive index is 1.3375. This is a historical mistake made since many years back, that the refractive index is 1.3375, as the cornea has a single refractive index, and this is the same which is used in the IOL master. However, the net power of the cornea is measured by two refractive indices, one for the anterior surface and one for the posterior surface. So what bother you as a surgeon, that when you want to calculate the intraocular lens for a patient who underwent keratorefractive procedures, based on this effective K reading, you probably have calculated the most accurate power of the lens for that patient. And you will find, for example, this is the holiday report, when they measure the effective K reading over a central zone of 4.5 millimeter. All the values are plotted in a histogram like this, and you can see the highest value is here, and this is another peak is here, and this is corresponding to the rule astigmatism. And the 65 means that they deduct 35% of the data, and the remaining data, they take the mean for the remaining 65%. So this is indicate that it is the mean 65% of the mean. So for example, this is the peak here is 43.5, and the other peak is 44 keratometry. Now the effective K reading is 44.3, because it take the mean for the 65% of the data. So this is the display you will see in the holiday report, and this is the effective K reading. You will find the steep and the flat effective K reading. This is in a brief the importance of the effective K reading in calculating the intraocular lens after keratorefractive surgery, and it is probably the most accurate one so far, better than the SIM K reading or other calculations. The last special power maps is the total corneal refractive power maps. It uses the same principle as the total net power map, that it measures the power of the cornea both from the anterior and posterior surface of the cornea using the real refractive index. That's why it cannot be used in a standard intraocular lens implantation, because there's difference between the sagittal map that measures the anterior surface only, and from the total corneal refractive power, which measures both the anterior and posterior surface. As you can see here, for example, if you look to this spot, the power of the cornea here is 47. However, in this is in the total corneal refractive power map is 46. However, this map is very useful in calculating the surgical induced astigmatism and in determining the power of the toric intraocular lenses. It is not used in the standard intraocular lenses, but used in the calculation of the toric intraocular lenses, or in the estimation of the surgical induced astigmatism in the limbal relaxing incisions. We can say that this map is useful in the presence of high astigmatism and in the presence of regular cornea. However, the effective power map that I have spoken earlier about it is useful in irregular corneas. In irregular corneas, better to go for the effective power map. By mean irregular corneas, that is in the presence of keratoconus or in the presence of post-surgical ectasia or after LASIK procedures. So in that cases, you better to use the effective K reading. However, in the presence of astigmatism with regular cornea, and to measure the toric IOL, better to go for the total corneal refractive power map. An important application of the total corneal refractive power map, TCRP, is it helps us in calculating the best suitable glasses for a patient with keratoconus who has a very irregular cornea, and sometimes even the autorefraction cannot give you a proper reading. In these cases, we depend on the corneal or topography data, the use of the K1 and K2 over the central 5mm zone, and we calculate what's known as the assumed manifest refraction. Assumed manifest refraction means the equivalent power for the glasses based on the K reading of the cornea. It depends on the principle that we presume that the spheric cornea has a power of 43.5 diopters, and the deviation of the K1 and K2 from this 43.5 diopters is estimated, and then we will prescribe the difference like that we prescribe spherocylindrical lenses. The difference that we will multiply by a correction factor for the glasses for any myopic value will multiply with 1.2, and with any hypermetropic value with 0.8. So we will reach finally to the assumed manifest refraction. This is as simple as that. So if we have example, this is a patient, for example, this K reading over 5mm, it should be over 5mm zone. So you should adjust your parameters because 3mm zone will not be suitable. As you know, the power distribution of the patient with keratoconus is a wide range over the central area, so better to use the 5mm zone. So for example, if you find the K1 is 45.2, we'll put it here. This is a steep one, and the other one is more, this is the flat one, sorry. The other one, which is 48.3, is the steep one. So we assume that the 43.5 is the spherical cornea. So we determine the deviation of the first meridian from the baseline. So the first meridian, that's 45.2, deviated by about minus 1.7 diopters. And we determine the deviation of the second one, which is, it should be around 4.8. But the difference between the two is 3.1. So as spherocylindrical lenses, we take the lesser power, which is we use it as a sphere, and the difference between the two powers is the cylinder. So it will be like this. So it will be a minus 1.7 slash minus 3.1 on the x20. And if we transpose it, we use the plus cylinder here, the plus cylinder. So the transposition will be equivalent to a minus 4.8 slash plus 3.1 x 110. This is the equivalent power, but we have to multiply this with the correction factor for myopia and hypermetropia. So we will multiply the minus 1.7 as it is, or the minus 4.8 as it is myopia, will multiply with 1.2, and we multiply the plus 3.1 with 0.8. So we will have the final conclusion like this. When we multiply the myopic value with 1.2 and the hypermetropic value with 0.8, so the final assumed manifest refraction will be minus 5.76 slash plus 2.48 in the x 110, and so on. So you can do the same principles for any K readings or any powers. And if you need more examples, there's examples in the Sinjab Academy series. There is a lot of examples for myopia and hypermetropia. I just like to explain to you the usefulness or the use of the total corneal refractive power map in patients with keratoconus. Another use of the TCRP, that's the total corneal refractive power map in the toric IOL calculation. As I said before, that this map measures the total corneal power, including the anterior surface and posterior surface, and it takes in consideration the thickness of the cornea.
by the process of ray tracing. So for any calculation of the toric IOL, we should depend on this map. We shouldn't rely on the SIMK, because the SIMK is using only the surface keratometry, that's the power of the anterior surface of the cornea. However, the TCRB using the total power of the cornea, including the taking in consideration the thickness of the corneal map. So you can see here, this is the printout report of the pentactoric IOL calculations. And when you see here, this is the power map of the TCRB. So the TCRB is more accurate and reliable for measuring the toric IOL. However, this map should not be used in ordinary IOL calculation. It should be only used in toric IOL calculations.
Here I would like to speak about the what's known as topographic astigmatism and manifest astigmatism. I'm sure that all of you know that the topographic astigmatism reflects the astigmatism from the anterior surface of the cornea that's measured by the topography. However, the manifest astigmatism represents the total astigmatism of the eye that's measured by retinoscopy or by the autorefractokeratometers. And in the topography map, you'll find the K1 and the K2, which represent the flat and the steep meridians of the anterior surface of the cornea. And the difference from them will give you the average astigmatism of the patients. The importance of this differentiation between the topographic astigmatism and the manifest astigmatism is that in the presence of skewed radial X deviations, now we have to look to the difference between the topographic and the manifest astigmatism. If the difference is less than 1 diopter, this reduce or neglect the importance of the skewed radial X deviation. As you know that skewed radial X deviation of the symmetric botai or asymmetric botai is one of the moderate or high risk factors for keratoctasia. But in the presence of difference of less than 1 diopter between the topographic and manifest astigmatism, this make this importance a little bit lower. The other thing, if the difference between the topographic and the manifest, the X less than 15 degree, also this is in favor of no asymmetry in the surface of the cornea and no ectasia. Another important point that also in the presence of skewed radial X deviation, and you find that there is what's known as enantiomorphism, that is mirror image of the two eyes, the appearance of the two eyes are mirror image to each other. This also decreases the importance of the skewed radial X deviation. Another thing that I would like to speak is the about the what's known as KM. KM is the average between K1 and K2. And for people who are doing LASIK refractive procedures, if you find the flat K is very low, that's less than 40 diopter, this carries the risk of free cap. And so you have to avoid doing or using the microkeratome in these cases, and you might change to another method of surgery like the PRK. And also similarly, if you find very steep cornea with more than 46, this carries the high risk of what's known as buttonhole. Another thing that was known as the Kmax. Previously, Kmax means the highest K reading in the cornea. And previously, the classification of keratoconus was based on the Kmax. However, the drawback or the limitation of the Kmax that the Kmax is not supported by a normative data, and the Kmax is not a good sensitive indicator or predictor of the progression of keratoconus, because to have a minimal change in the Kmax, you need the disease will have significant progression before you have a minimal change in the Kmax. So it is not a sensitive indicator for the progression of keratoconus. However, the Km will be better indicator, and it has support from the normative data. So better to rely on the Km in the assessing the progression of the keratoconus and not in the Kmax. Last point that you know that as I explained earlier, the manifest astigmatism and the total corneal astigmatism, the placido disc-based topography will measure only the anterior surface astigmatism. But we have also astigmatism in the posterior surface of the cornea, although it is not that much big, and it has minimum influence on the total astigmatism. But some cases, especially those with the posterior element keratoconus in the posterior surface of the cornea. So the Placido's disc-based topography will measure only the anterior surface astigmatism. So if we want to have an idea about the total astigmatism of the eye, we rely on the manifest refraction, and there is another term known as the internal astigmatism, that if we deduct the total astigmatism of the eye, I mean total, I means the lenticular and the corneal, which is measured by autorefractometer, and then we deduct from it the topographic astigmatism, that is the astigmatism of the anterior surface of the cornea. What's left behind is the internal astigmatism. The differentiation here is important because usually the anterior surface of the cornea is responsible for more than 95% of the astigmatism of the eye. And now there is what's known as the topographic guided ablation. So if you find that the main source of astigmatism is due to the anterior surface of the cornea, so in these patients, the topographic guided ablation will be useful for them to handle the astigmatism. However, if you find the contribution of the anterior surface of the cornea is not that much to the total astigmatism of the eye, so in such cases, you have to look for another way to correct this astigmatism by changing the lens and putting a toric intraocular lens, or by doing combination of both corneal ablations as well as toric IOL implantations. Now, after we finish the curvature maps, all the types of the curvature maps and the special power maps, now the time came for the elevations maps, that we have to speak in details more about the elevations maps, either the anterior and posterior elevation maps, and the special display, that's the bad display or Belen-Ambroso display for the elevation maps. Now, after finishing speaking about the curvature maps and the different types of curvature maps and the advantages and disadvantages of the curvature maps, we come to the elevations maps. And there are three important points that I would like to explain and emphasize. That elevations maps represent a true shape representation of the cornea. As we said that in the projection-based topography or elevation-based corneal topography, it primarily measures the elevations of the cornea, and also this will gives a good information about the curvature of the cornea. However, the Placido-based or reflection-based topography, it primarily measures the curvature, and by particular calculations and assumptions, it can gives information about the elevations. However, is not as accurate as in the projection-based corneal topographies. Another thing, that the elevations maps are independent to the axis or the orientation or the positioning of the patients. Even if the eye is moving somewhere, the elevations will be properly represented in the elevations map. However, in the axial maps, this is very detrimental factor or variable that the patient should properly fix to the topographers, and the variations of angle of Kappa due to poor fixations will gives a large range of variations in the shape of the curvature of the cornea, and sometimes lead to misdiagnosis of keratoconus. And this gives the advantage for the machines that were equipped with the auto capture options. There are some machines like in the TMS5 that I am using in Tripoli Medical Center. It has a function of the auto capture feature, that if the patient is not well aligned, the machine will not take the picture. And this is done to overcome the bias due to poor fixation of the patients. Now, this poor fixation variable is not important in the elevation maps. The curvature map is mandatory, and it is very important. So in the elevations maps, it primarily measures the elevations, and the curvature is secondary derivatives. However, in the curvatures maps, it primarily measures the curvatures, and it can give some information about the elevations. And the elevations maps is represented by a scale with the cold colors and hot colors, as you can see in these pictures. And of course, the hot colors represent elevation above the best fit sphere, and cold colors represent below the best fit sphere. And by best fit sphere, we mean the reference surface. It can be a best fit sphere, or best fit toric ellipsoid, or best fit toric sphere, or the enhanced best fit sphere by Ambrosio. Another concept that I would like to explain the difference between the curvature and the elevations. Now, these two pictures, they have the same curvatures. However, as you can see in the right side, it has a higher elevation as compared to this. So this is very important to understand that the curvature does not mean the elevation. The elevation gives more information about the shape, as you can see here. However, this is the curvatures, gives you the power of the cornea, but not much information about the exact shape of the cornea. After finishing speaking about the curvature map, now the time comes for the elevation map. The elevation map is very important in giving information about the real protrusion on the surface of the cornea and about the shape of the cornea. And as you can see here in the quad map, this is the quad map for a normal cornea, and this is the anterior elevation map, and this is the posterior elevation map. This is represent the anterior surface of the cornea. Normally, as you can see, this is the green color indicate that this is the mild elevation in the center, and the blue color indicate that mild depression in the periphery, and this is correspond to the prolate shape of the cornea, in which there is central elevation with peripheral depressions. However, if you see to the color code of this map, usually it is the reverse of the curvature map. As you can see, with the rule astigmatism, mild degree, with the steepening of the vertical meridian and the flattening of the horizontal meridian. So you can see that the colors are reversed because of the steepening. Hot colors are present in the vertical meridians and cold color in the horizontal meridian. However, in the elevation map, because of the elevations in the center and depression in the periphery, you can see the reversal of the colors as compared to the curvature map. So it's important always when you interpret the finding, look what you are reading. Are you reading the axial map or the elevation map? Because the interpretation will be different. And the color code, better to use the 5 millimeter color scale for the elevation map, which gives a standard color scale. Use the 5 micrometer color scale. This is the posterior elevation map, which is also represented here in the display, and usually this is the location for early detection of keratoconus, usually common in the posterior elevation map. As you know that the normal shape of the cornea is a spheric and toric ellipsoid, and to study the elevations that present in the cornea, it should be compared with the reference surface. And the reference surface, there are many types, but the most common is the best fit sphere, which is this one that we compare the curvature and the elevation of the cornea with using the best fit sphere, which is a regular sphere with equal radius of curvature in all directions. This way of assessing the corneal elevation is very useful to give a good localization of the cone, and also useful for screening for keratoconus. Another type or another reference surface is the best fit toric ellipsoid, in which it is to large extent resemble the shape of the cornea, and it gives the details of the shape of the cornea and the height of the cone. It is very useful in assessing the progression of keratoconus. So this one for the screening of keratoconus, and this one for progression of the keratoconus, as we will see later on in the Pentacam maps, that when we use the keratoconus progression analysis, that we will use the best fit toric ellipsoid. The best fit sphere should be placed manually in the machine as 8 millimeter best fit sphere. Also, you have the other options of use the best fit toric sphere or other sphere, but the standard to use the 8 millimeter best fit sphere, because any mistake in the placement of the reference surface will gives you a wrong interpretation of the data. For example, this is for the same patients who underwent topography. You can see clearly that there is a hot spot in the center of the cornea. This is using the 8mm best fit sphere. The same patient with using a 5mm best fit sphere, you can see there is masking of the hot spot in the center. And this is with a 10mm best fit sphere, it is overestimate the central hot spot. So it is very crucial to put it manually and make sure that it is in the 8mm. This is the standard. As we spoken before, that the elevation of the cornea is assessed in relation to the reference surface. And the reference surface, we have different types. The most common and the most standard method is the best fit sphere. And the best fit sphere, it is calculated by the machine itself from the average K reading of all the cornea. Now, the cornea, when it is measured, there are different radii of curvatures, and the machine will have the average of this K radius of curvatures and the K readings, and accordingly it will construct a reference surface that's fit for that cornea. It's made by the average of radii of curvature of all the locations of the cornea. Now, this reference surface or the best fit sphere can be in a flotation mode or a non-float mode. The float mode means that there is no constraints and the apex of the cornea will be above the reference surface, and any point of the cornea that's above the reference surface will have a positive value in microns, and any area below will have a negative value in microns. Similarly here, the non-float modes means that the apex of the reference surface should touch the apex of the cornea, and all the points of the cornea will be below that reference surface. And this is exactly similar to the float of the flotation of the person when he's in water. So if he's freely floating in the water without any constraints, so part of his body will be above the water and part below. This is called the float mode. And if there is constraint, and we study the elevations of the surface in relation to the top of the water like this. So this is called non-float mode. So the reference surface should just touching the apex of the cornea.
And this representation of the relation between the apex of the cone and the best fit sphere, as you can see that the apex of the cornea in like this case falling above the best fit sphere, so it has a hot colors which will appear as a red here. And those areas which are falling below the best fit sphere will be in cool colors, and they will have the appearance of the blue color. Now this map named as a central island on a sea of blue area. So this is very suspicious of keratoconus and should be taken seriously. So this is the distribution of the colors and the relation between the apex and the best fit sphere.
The other parameter that we should look for when we look to the elevation map is the pattern of the display. Always we look to the numerical data and also look to the pattern, because there is normal patterns and there is abnormal patterns. Now, the normal pattern of the cornea with a mild withdrawal astigmatism is known as symmetric hourglass pattern, in which there is central mild central steepening, and there will be depression below the reference zones in the vertical meridian, as this is with the rule astigmatism, and there will be flattening and mild elevations in the other meridian. This is a normal appearance of the cornea in a patient with mild with the rule astigmatism. Also, another mild or another normal appearance of the cornea in case of the cornea is totally spherical. If that eye is totally spherical, also you will find a central island. This is called isolated central island. This is because the apex of the cornea usually just above the reference surface, surrounded by area of green that's touching the reference surface, and another area of blue due to this area is below the surface. To understand this exactly, if you look to this, the reference surface, the best fit sphere, so that part of the cornea which is normally above the reference surface will be appear in the yellow color, and that part which is touching the reference surface will form a ring of green zone around the central island, and those parts which are below the reference surface here, the yellow color, this is the cornea, will be in the blue color. So you find this is a blue color. So this is also a normal pattern, but this is a spherical cornea, and the previous one was mild with the rule astigmatism. However, this pattern sometimes becomes suspicious if these findings and these colors are accentuated, like in this case, for example, this is accentuation of the central apex, and followed by two colors, that's the red and then the yellow, so it indicates there is significant elevations in the center. So this is more suspicious of isolated or the nipple cone, especially the nipple cone. Another thing that I would like to emphasize about the color code and the difference between the elevation map and the axial map. Now, as you can see here, the elevation map, the blue color here, the blue color indicate that this area is below the reference surface. And since it is below the reference surface, it is more steeper. So in the axial map, you will see this area is to be in red color. However, the other meridian, because it is in red in the elevation map, so it is elevated than the reference surface. And since it is elevated, so it is flat. So in the axial map, you will find it blue. So the reversal of the colors, you should note this. When you look to the map, you should identify first whether this is an axial map or this is an elevation map. If it is an axial map and you find the redness in the vertical meridian, this is indicate with the rule astigmatism. If it is elevation map, you will find the blue color in the vertical meridian. Also, it indicates with the rule astigmatism. And the common reference surfaces, that there is the best fit sphere. This is the most common, and as I said before, this is usually for screening of keratoctasia and for initial diagnosis. And the best fit toric ellipsoid, this is commonly used for the confirmation of progression of ectasia. And in cases of already established keratoconus and we want to follow them, better to follow them with the best fit toric ellipsoid. The other new reference surface is the enhanced best fit sphere or of Bell and Ambrosio, and this is peculiar also for keratoconus, and I will speak about it in separate slide. Group B in the elevation map based patterns is the irregular patterns. The irregular patterns, like the hourglass pattern with skewed deviations, this is one of the abnormal or irregular patterns. Also the tongue-like extension, which is seen in the elevation maps, and multiple other irregular patterns like the D-shaped and multiple irregular surfaces. So this is indicate that there is an abnormality, but we cannot take a decision, a final decision, just by looking to the shape. We have to look to the cutoff values and compare with the cutoff values so that we can, on a solid ground, we say that there is abnormality or there is no abnormality. The second type of the fit sphere that we use to compare when the presence of irregular cornea is what's known as the best fit toric sphere, or another one is best fit toric ellipsoid. And this is useful in the presence of highly irregular corneas like in keratoconus and also in post-keratoplasty or post-LASIK ectasias. So the same principle of the best fit sphere, and the different areas, as you can see here. This is indicate this area is above the best fit toric sphere, and this blue indicate that this is area below. Usually this patient better to go for aberrometry and determine the different wavefront operations for them to determine the cause of the poor quality of vision, and you can manage accordingly. However, to study the elevations, better to use this one of these two surfaces. To understand the difference and the applications of the best fit sphere and the best fit toric ellipsoid, you should remember that the normal shape of the cornea is toric ellipsoid. But the best fit sphere is the most common standard difference surface that is used in the most common standard display of any corneal topography, especially in the presence of regular cornea. It is very useful in determining the apex of the cone and early detection of the keratoconus, and describe the shape of the cone. And along with the posterior elevation maps, it is very useful in early detection of keratoconus, and also useful in the classification of keratoconus as central or paracentral or peripheral based on the elevation map using the best fit sphere. However, in the presence of irregular cornea, especially keratoconus, clear case of keratoconus, better to use the best fit toric ellipsoid because it is very close to the normal shape of the cornea. And some people say that it is more useful in the detection or documentation of progression of keratoconus. That's why in Holiday report, they commonly use the best fit toric ellipsoid reference surface, and they claim that it is useful in early detection of keratoconus. But most of the doctors, they believe that the best fit toric ellipsoid is useful in the follow-up or documentation of the progression of keratoconus. This is the table shows the some of the cutoff values for the elevation maps using the best fit sphere on Pentacam, and using the anterior and posterior flotation maps. Now, this cutoff values are important because it is related to the thinnest point of the cornea as well as to the apex of the cornea, and we have different values based on the standard deviation. Usually the value with the 3 standard deviation is the one which is used that provide a safety confidence interval. So this data usually commonly used by doctors, and also is found in the Sinjab Academy. This data is popular between doctors, and also in the practical sheet that has been made by Sinjab Academy, these figures also has been used. So you need not to memorize all these figures. However, most of the machines are equipped with a alarm system that when there is any deviation from the normative data, there will be some yellow flag indicate that he's at mild risk, or a red flag that he's at high risk. Some of the cutoff values for the elevation map, as taken from the Dr. Sinjab assumption in Sinjab Academy, is that the elevations maps of on the anterior surface, if it is more than 15 microns, is highly risky, and if the elevation map over the posterior surface over 20 microns is highly risky. And if the difference between the anterior and posterior elevations more than 5 microns is also highly risky. However, the elevation over the thinnest point, if the patient is myopic, the anterior surface should not exceed 8 microns, and the posterior surface should not exceed 18 microns. In hypermetropic patients, the anterior surface should not exceed 7 microns, and the posterior surface should not exceed 28 microns. This is for the best fit sphere. If you use the best fit toric sphere, the elevation over the anterior should not exceed more than 12, and for the posterior should not exceed over 15 microns. Now, I would like to speak now about one important display, which is the Pillin-Ambrosio enhanced ectasia display. Now, this display meant merely for abnormal corneas in which there is suspicion of being ectatic cornea, which is not very clear or evident with the best fit sphere. So they postulate that to use a special reference surface known as the enhanced best fit sphere. The idea based on that, the classical best fit sphere will not clearly show the abnormalities in the cornea. As you can see here in this reference surface, part of the abnormality is below the reference surface and the other part is above, which might not be very clear in the normal display. However, if we exclude the central 4 millimeter from the reference surface so that the reference surface will fit to the cornea, now the abnormality is very clear and evident here. So if you can see the display made up of 6 maps, 2 for the best fit sphere and 2 for the reference enhanced best fit sphere, and 2 is a difference map from the normal. Now this is the anterior elevation map and this is the posterior elevation map. This is the best fit sphere. You can see that the anterior elevation map is normal and very mild changes seen in the posterior elevation map. However, with the use of the enhanced best fit sphere, now the elevation becomes more prominent in the anterior elevation map and very clear in the posterior elevation map. So that's why it's called enhanced best fit sphere. Now this is the difference map, is the deviation of the patient's data from the normal. You can see clearly here the red color indicate abnormality and the deviation from the normal, which is evident both in the anterior and posterior surface of the cornea. Similarly, this is the corneal thickness spatial profile that I have explained before. So the bad display based on we use a reference surface after excluding the central 4 millimeter. And this is the 5Ds. This is the 5Ds that is we look for to determine the abnormalities of the cornea, but we need not to memorize the values because the machine itself would shows you if it is a yellow color indicate suspicious, and if it is red indicate definite abnormalities. And these 5Ds include the anterior and posterior corneal surfaces and the pachymetry and different ratios. However, what's important for us is the final D here. So even if 1D here is red and the final is yellow, this indicates that this patient is suspicious. We don't take a decision based on a single index of them, but we take the decision based on the final D here. And of course, you have to make sure whether your patient is myopic or hypermetropic, because the values here differs from myopia and hypermetropia. The normal D is 1.6. If it is more than 0.6, indicate that this patient is suspicious. If it is more than 1.8, it is indicate that this is definite abnormality and will be highlighted in red. Now this is an example using the bad display and in a patient for both eyes. One of the eyes is typical and definite keratoconus, and the other eye is suspicious. This is called a very asymmetric keratoconus or ectasia. So you can see clearly here that this is the best fit sphere shows abnormalities, and when we use the enhanced best fit sphere, it becomes very evident. And this is the difference map. Similarly, the spatial profile of the corneal thickness is abnormal, and what's important for us is the index here, all are in red, and the bad value, this is the bad value, which is 7.8, which is very abnormal. Value more than 2.8 indicate this is abnormality, and this is the value of 7. So this is a definite case of keratoconus. However, when you look to the other eye in the best fit sphere, it looks normal. However, when you use the enhanced best fit sphere, it shows abnormalities in the posterior flotation map. Even the difference map, there is no any abnormality. So this is very suspicious to be keratoconus. However, when you apply the indices, indicate this is a yellow color, so it is suspicious. Could it be a form of rust keratoconus? Because as you know, keratoconus is a bilateral disease, but very asymmetric. Sometimes you find one eye with severe keratoconus and the other eye is very mild. So the advice is always look to both eyes. Don't look or diagnose just a single eye. Always look to both eyes. If your patient came with this eye, you have to look to the other eye. Or if the patient came to you complaining of this eye, you should look to the other eye. The other thing that keratoconus is very asymmetric. Sometimes you'll find one eye with very keratoconus and the other eye is completely normal, but this doesn't mean that it is fit for keratorefractive surgery, as this might be a form of rust keratoconus. Now I finished the important points regarding the curvature map and the elevation map. And before I go ahead to the pachymetry map and the other added displays, I would like to speak about certain important points. Number one, the QS value. That's the quality specification. When you look to the map, the first thing you look to the quality specification. The quality specification indicate that
your capture is okay and is validated. However, this doesn't mean that your patient has a good alignment. So even if you find the capture specification is okay, this doesn't mean that it is an okay, because even if the patient has poor alignment, it will give you okay sign, and at that time you will interpret the data wrongly if you don't know that there is variations of the angle of Kaaba and the patient is not well aligned. The alignment of the patient is should be determined by comparing the two eyes, comparing the X and Y coordinate of the two eyes. Normally, both the Y coordinate and the X coordinate of the both eyes should be less than 200 microns. That is 0.2 millimeter if we add them together algebraically, and the summation or the subtraction of the two Y should be less than 200 millimeters algebraically. Algebraically means we use the plus sign and the minus sign. So if you find these figures, this indicates that your patient is well aligned. However, if you find figures more than these values, this indicates that your patient is not well aligned, and you have to repeat your capture again, or you look if your patient have variations of angle of Kaaba. The other thing that I have spoken before, that in the presence of skewed radial X deviations, this is an important finding that you should take in consideration and raise the suspicion of keratoconus. However, this variable is neglected in the presence of what's known as enantiomorphism, and also when the difference between the topographic and astigmatism is less than 1.5 millimeter. The difference between topographic and the total astigmatism less than 1.5 diopter. And also, as I said before, that the Km value is more sensitive parameter in keratorefractive procedures because it is supported by the normative data, unlike the Kmax value. In Pentacam, if the Km more than 48, this makes the patient has a moderate risk. However, in the other placebo-based keratometers, a value of more than 47.2 has a moderate risk. Another thing that don't forget to use the absolute scale for the curvature map, and use the 5 micrometer scale for the elevation map and the 10 micrometer scale for the bathymetry map. Now, after we have finished the curvature maps, the axial and the tangential map, and the special power maps, we finished the elevation maps with the anterior and posterior elevation maps using the best fit sphere and the best fit thorax spheres. And we studied also the bed display, the Pellin Brosso display. Now, the next session will be regarding the corneal thickness, as either the bathymetry map or the thickness spatial profile. In the bathymetry map, there are certain important landmarks that we have to concentrate on. First of all, you have to make the scale of the bathymetry map the 10 micrometer scale. This is the standard scale for the bathymetry. And the bathymetry important landmarks is the corneal apex. That's the bathy-apex, the thickness of the cornea over the corneal vertex, and the thinnest location of the cornea. The third thing is the opposing 2 points, the superior and inferior point along the vertical meridian within a central millimeter circular zone. These are very important to understand the corneal bathymetry. Another thing is the study of the corneal spatial corneal thickness profile. This is another important that we not just looking to a single point per se, but we have to look to the overall thickness profile of the cornea. Now, if there is a difference between the two eyes, inter-eye asymmetry, and as far as the bathymetry of more than 30 micrometer, this indicates that there is abnormality. Normally, it should not exceed more than 30 micrometer. And I would like to emphasize here that when we say that there is abnormality, this doesn't mean keratoconus.
because keratoconus is a syndrome composed of multiple parameters of abnormalities. So we cannot just diagnose keratoconus by finding one parameter is abnormal. So when we say there is an abnormality, this should be added to the other abnormalities that you can find in the elevation map and the curvature map and the inter-eye symmetry. And at the end, you can give the diagnosis of keratoconus or abnormality or ectasia or so on. So we will not rely on only one single figure to diagnose keratoconus. The other difference between the superior and inferior points should not exceed more than 30 microns between as far as the thickness. And the other thing is that the location of the thinnest point should not be more than minus 0.5. It is more than minus 0.5 along the y coordinate. This will indicate an abnormality. And when we say minus, it means that it is below the corneal vertex or below the corneal apex. The minus sign indicates that it is below along the y coordinate. Lastly, you should keep in mind that the pachymetry is very useful also in the diagnosis of glaucoma, and maybe it is an independent risk factor of glaucoma. So studying the corneal thickness is very important. In the next slides, we'll speak also about the cornea spatial corneal profile, and we study the distribution of the thickness of the cornea from the peripheral part of the cornea to the central part of the cornea, as this is very important in diagnosis also of keratoectasia. Before speaking about the pachymetry and the thickness, there are certain important overlays should be understood, because it will help us to understand more about the data extracted during the pachymetry. The first overlay is the black and white dashed perimeter that you see here. This represents the pupillary margin. This is captured by the machine by the help of the ray tracing, and can determine the margin of the pupil. So when you see this black dashed line, this indicates the site of the pupillary margin. The second plus sign here, the black plus sign here that you see, this is the means that this is the pupillary center. This is the location of the pupillary center, and this is important because this means this is the location of the pupillary axe. When we'll speak later about the angle of alpha and angle of kappa, we will need these important relations. The third important overlay is the brackets that you can see here. This is the geometric center or the limbal axe. This location is determined by measuring the horizontal white to white diameter, and in the center of this horizontal white to white diameter, exactly this is the geometric axe, and this is called the limbal axe. The other white circle here is reflecting the first Purkinje image. This is the location of the visual axe, and also this is called the corneal vortex, assuming that the corneal apex correspond to the visual axe. So this is the location of the visual axe or the corneal vertex. The point that you can see down here, this is the location of the thinnest point of the cornea. So when you find this circle, this is indicate that this is the thinnest point of the cornea. The thinnest point of the cornea should not correspond to the apex of the cornea, and normally there is some XY deviation within normal limits. Beyond that limits indicate that there is abnormal. So when we say pachy-apex, means the thickness over the apex of the cornea, and when we say the thinnest point, indicate the thickness over this area. After we have an idea about the normal shape of the cornea and the normal pachymetry of the cornea, now there are certain abnormal patterns of the cornea that you should comment on before you read the numerical data. So you will have a numerical data, and also you have a descriptive shape of the cornea as far as the thickness of the pachymetry. There are different abnormal shapes like this one. This is the dome shape. That's a small island of abnormality or thinning surrounded by a large area of normal cornea. As compared to this one, the last one is the large area of thin cornea surrounded by a small zone of normal cornea. This one is known as the droplet pattern, and that one is known as the dome shape. These are abnormal patterns of the cornea as far as the thickness of the pachymetry. Another thing is the pill shape. This is the shape of the pill. This is the mouth of the pill, and this is the shape of the pill. This is specific and peculiar to the pellucid marginal degeneration, that the thinning is maximum at the peripheral part of the cornea, reaching up to the limbus. Another thing, when you find that there is horizontal displacement of the thinnest point, as you know that the thinnest point normally is just below the corneal apex and within a range less than 0.5 millimeter. In keratoconus or keratoctatic diseases or abnormalities, you will find more displacement along the vertical coordinate, more than minus 0.5, or also you will find horizontal displacement of the thinnest point or thinnest location. The other thing is the generalized thinning of the cornea, like this in keratoglobus, you'll find a generalized thinning reaching up to the lumpus. These are all are abnormal shapes of the cornea as far as the pachymetry is concerned. Another important display of the pachymetry map is the relative pachymetry map. A relative pachymetry map, because we compare the current pachymetry map of the patients with the normative data, so that we compare this map relatively to the normal map, so that we come up with the conclusion that how much the current map is deviated from the normal. For example, this is the normal corneal thickness, and this is the patient's current pachymetry map, and we will subtract this one from this one. So we come up with a relative pachymetry map that shows how much your patient is deviated from the normal. And you can see clearly here that there is too much deviation from the central part of the cornea from the normal. This is called relative pachymetry map, which is an important component of the Pellin and Ambrosio display. What are the limitations of the pachymetry map? There are certain limitations of the pachymetry map, that in the presence of corneal opacities, it might give an artifact, and also it is sometimes it gives a flattening of the cornea in the presence of scars, and also sometimes interpreted as a thin cornea, which is not always true. So preferably advised when there is a central corneal scarring, especially in cases post-acute hydrops, better to use the OCT, anterior segment OCT, to have a good details about the thickness of the cornea and compared with the thickness taken by the pachymetry map. Now we come to another display in the thickness profile, in the thickness map, which is known as the corneal thickness spatial profile. This profile study the distribution and the progression of the corneal thickness from the thinnest point of the cornea to the toward the periphery of the cornea. As you know that the thickness of the central cornea ranges normally around 500 micrometers, and at the periphery around 650 micrometers. So this progression is in a normal cornea is usually smooth and regular. However, in abnormal corneas, this progression is not uniform and sometimes deviate and have abrupt changes along the course. Now, what's important for us is the progression of the thickness of the cornea within the first 6 millimeter zone is very important. So we have two graphs. We can study the spatial profile by presenting two graphs. That's the CTSP graph, that's the corneal thickness spatial profile, and as well as the percentage thickness increase. This is presented in this is the presentation of the raw data with two confidence intervals, 5 and 95%, and the middle line is represent the average, and the red line is the raw data of the patients. Now, as long as the raw data of the patients falls within these two confidence intervals, this indicates the progression is normal. However, any deviation from these two tram-like lines, this indicates that there is abnormality. Now, when we present this raw data in a percentage form like this, similarly, we have two confidence intervals here and the average in the middle. If it is deviated from these two tram-like lines, this is indicate that there is abnormality So the corneal spatial profile is measured by around 22 concentric rings from the thinnest point toward the periphery, each ring of about 0.4 millimeter. And it studies the normal homogeneous distribution of the corneal thickness from the center to the periphery. Now you can see this is the normal distribution of the corneal thickness spatial profiles. This is the red line in the middle, so this is indicator normality. And what's bothering us is up to the 6 millimeter. We have studied the pollution up to the 6 millimeters, so that we know that this is a normal cornea or abnormal cornea. Now, from this data, we can extract what's known as the Biomechanics progression index. This Biomechanics progression index normally ranges between 0.8 to 1.1 millimeter. Any value below the 0.8 indicate thick cornea, like any endothelial problem like Fox endothelial dystrophy or cornea gattata. And a value more than 1.2 indicate thin cornea or ectatic problem. This is an important index. So this in brief the importance of the Biomechanics map and the different displays that we can extract, like the corneal thickness spatial profile and percentage of thickness increase. Here are some examples of the corneal thickness spatial profile. As you can see in this example, the curve is going up. The curve is going up for the patient, which indicate inverted curve. This is usually peculiar for pellucid marginal degenerations. And when you look to this curve, there's a rapid slope with rapid decline. You can see within the 6 millimeter zone, there's a rapid decline of the curve. And this is indicate the early keratoconus or form of rust keratoconus. This is known as S-shaped. So this is abnormal corneal thickness. Similarly here also there is a rapid decline within the 6 millimeter zone. You can see the percentage thickness increase also in the border line below the 3 tram lines here. So this is also indicative of thinning of the cornea and keratoectasia. And you can see that the progression Biomechanics progression index also more than 1.1. Similarly here, the progression Biomechanics index less than 0.8, which indicates thick cornea. And the curve is going straight like this, straight curve, flat curve. So this is indicate thick cornea, like in the pellucid, like in the Fox endothelial dystrophy or edematous cornea. Now we come to the last session, that's the special displays. After finishing the curvature maps, elevation maps, the thickness maps, including the thickness spatial profile. Now we left with the special maps, that's the holiday report and the keratoconus progression displays. The holiday report is a very important report in the Pentacam printout that invented by Jack Holiday along with the Oculus company. And this report contains the most important informations as far as any refractive surgery or before cataract surgery and the planning for premium IOL implantation. And this report made for any busy practice in which you need to classify or assess the patient properly before any refractive surgery, because it contains all the data that you need to take a decision regarding your patient as far as refractive surgery. So it is very important component of the Pentacam printout, and should be read carefully and understand all the items including this report. This report mainly contains of three columns and three components. The first left upper zone contains the demographic data of the patients, and then there is a middle zone and right upper zone. We will go in details for the middle upper zone and the right upper zone. Now we will speak about the holiday report, the middle upper zone. The first zone is for the demographic data, but the middle upper zone contains some important data. The most prominent one is the EKR 65. This EKR 65 is a special K reading measurement done by the pentacam, and this measurement reflects the power of the cornea over a 4.5 millimeter zone, and it takes in consideration both the anterior and posterior surface of the cornea. The 65 stands that it takes the 65 percentile, and it doesn't mean that the mean, but it mean not the average. It doesn't take the average, which is the 50%, but it takes the mean, the percentile of 65. So it is named effective keratometric reading. That's EKR 65, both the flat and steep meridian and the astigmatism. They say that this power or this measurement is very useful in IOL calculation, whatever type of IOL you are using. And at that time, you don't need to have any a constant compensation for that IOL calculation. By the use of AKR 65, you don't need the A constant anymore. I will speak about the AKR 65 later on in another slide with more details. The other parameter will be the Q value, which is a reference to the sphericity of the cornea. As you know, the cornea, normal cornea is prolate shape, which is more steeper in the center and becomes more flatter as you go toward the periphery. And the normal sphericity of the cornea is around minus 0.26 to minus 0.27. And the other parameter is the total spherical aberrations at both the fourth Zernike polynomials, grade and 6 and 8 and 0. The spherical aberrations, I will speak about it in the lecture of the aberrometry, but our aim in IOL calculation is to neutralize the spherical aberrations that is present in the optical system of the patients, and to keep them at the 0 level or at minus level, preferably to be in the minus level, because this will increase the focus of the patients and will increase the depth of focus, and he will be able to read more. And of course, when we neutralize the spherical aberrations, we will improve the quality of the vision of the patient, improve the contrast sensitivity, and you will find a patient satisfaction. For example, this patient has plus 0.24. This is the spherical aberrations. So better to use a negative spheric lenses that neutralize this power, make him 0, or to keep him in the negative side. The ratio, the back to front ratio, is the ratio of the curvature of the front surface of the cornea to the back surface of the cornea. This is very important, and this is the normal, because by this ratio we can predict what was, suppose you have a patient who has underwent LASIK surgery, and now you want to calculate the intraocular lens. All the measurement they need the K reading before he has done the LASIK or refractive surgery. So we cannot have the idea about the K reading that was present before he's doing the refractive surgery. But now, by knowing the back surface curvature, by a certain percentage, we can know what was the curvature of the anterior surface of the cornea before he underwent a refractive surgery. This is called the back to front ratio. The last measurement is the RMS HOA, which is the root mean square high order aberration wave front error. This is also, we will speak about it when we speak about aberrometry, but this is a reflection of what will be the quality of vision of your patient after doing the premium IOL implantation. And if a patient has a high value, more than 1, this make him he will be very unsatisfied with your premium IOL, and better not to implant premium IOL like a multifocal IOL or diffractive lenses. Better to use him monospheric lenses. A value between 0.6 to 0.1 is a borderline or a gray zone, so that it depends on the forgiveness of the patient, whether he will accept minor aberrations and halos. But if it is less than 0.6, it is okay. So the root mean square is very important. If, for example, this patient has a reasonable RMS value, so this patient will be a good candidate for premium lens implantation. This is one example of the holiday report. At a glance, once you look to the report, it's important to look to the colors, so that when you find a red color, indicate that there is an abnormalities. White color indicate everything within normal limits, and yellow colors indicate borderline or in the middle zone. So, for example, this is the RMS HOA, which is the root mean square for the high order aberration wave error. Normal values of this item should not exceed more than 0.37 micrometer. This represents the total aberrations present in the eye, which is mainly due to corneal origin. Now, this patient has a 1 micrometer, which is very high. This indicates that this patient, even if you implant a premium lens or multifocal lens, he will not be happy because of the high order aberrations that's present due to compromised cornea. So better in such cases avoid to implant multifocal IOL during cataract surgery and go for a monofocal lens surgery. So by this report, we can guide the selection of the intraocular lens that we are going to implant to the patient. So this is the RMS HOA, which is very abnormal in this case. The right upper panel of the holiday report carries also some important information about the pupillary diameter and what's known as the horizontal white wide diameter, which is used by many IOL calculation formulas like the Holiday 2 to estimate the effective lens position, the ELB, that's the effective lens position. The minimum or Paki minimum, that's the minimum thickness of the cornea. Normally, there is a relation between the thinnest point and the corneal vertex. Normally, the minimum or the thinnest point of the cornea lying a little bit temporal and below the corneal vertex, not more than 0.6. If it is more than 0.61, this is may make the patient suspected to be keratoconus. So you can see that in this patient, the thickness is 550 microns. This is the temporal location, and this is the inferior location. You can see this is 0.4 inferior location, so it's still within the normal limits. If this value is more than 0.61, this indicates this patient more likely he has a keratoconus. The estimated pre-refractive KM is the if you have a patient with underwent LASIK procedure or any keratorefractive procedure, you want to know what was the K reading before doing the surgery. So by knowing the curvature of the posterior back surface of the cornea, there is a fixed ratio between the back surface of the cornea and the front surface of the cornea. So we can estimate what was the curvature of the anterior surface of the cornea before doing the surgery. And we deduct it from the current K value of the patient, and accordingly we know the refractive changes of the patients after that keratorefractive procedure. For example, this patient has a plus 0.2 diopter, which is very negligible, so unlikely that he has underwent any keratorefractive procedures. The AC depth external, which is the thickness of the anterior chamber or the width of the anterior chamber from the corneal vertex, that's from the epithelial side, up to the anterior surface of the lens. This is also used in some IOL calculation, especially for phakic AC IOLs. Now, the chord mu, this is used in the pentacam. Pentacam is not measuring the angle of kappa, but measure something similar, which is known as the chord mu, which is the distance between the pupillary center and the corneal vertex. Normally, it has a range between 0.2 to plus minus 0.1. Now, if this value is greater than 0.42, this indicates that your patient is not suitable or good candidate for multi-refractive or multi-diffractive, multifocal IOL or diffractive IOL, because he will complain of hair loss. So this is very important. The chord value of more than 0.42 make your patient is not suitable for any sort of diffractive intraocular lenses. Now this patient has a 0.08, which is still within the normal limits. Now I would like to speak about a new term or new definition mentioned in the Pentacam report. That's the chord mu. Now, this chord mu is represent the distance between the visual axis and the center or the pupillary axis at the iris level. As you know, the angle of kappa and the angle of alpha has very great importance in any type of refractive surgery in the form of keratorefractive surgery or intraocular lens implantation. Especially in the LASIK procedure, the people with large angle of kappa, they usually end up with unhappy and some refractive surprises and complain of halos because of the large angle of kappa, especially in hypermetropic patients in which the center of ablation will be displaced. And you know, the normal angle of kappa is around 5 degrees, and it is getting more in people with hypermetropia. And the angle of alpha is the distance between the visual axis and the center of the limbal axis. That's the limbal axis means the center between the white diameter. When the topography measures the white diameter, the central point of that line represent the geometric or the limbal axis. So the angle between that axis and the visual axis is known as the angle of alpha. And the angle of alpha is gaining importance in the late decades after the innovations of the premium lenses and the enhanced depth of focus lenses and the toric lenses. They found that for ideal proper centration of the intraocular lens in the capsular bag, it should be taken in consideration the angle of alpha. People with large angle of alpha, they should you should not implant such type of premium lenses, because the patient will not use the optical axis of the lens, but he will use the edge of the diffractive intraocular lens, so that he will complain of glare and halo, and he will be unsatisfied. So for a proper machine, we have to measure the angle of kappa and angle of alpha properly. Now, in the Placido disc-based topographers, because they take the measurement of the visual axis and the pupillary axis from the surface of the cornea, and the surface of the cornea is magnifying the image, so it will not give the proper location of the center of the pupil. In reality, it will make it more shifted more temporally, and the image will be more magnified. So the calculation will be different a little bit and is not that accurate. However, in the sham float based topographers like the pentacams, it measures the distance exactly at the level of the iris plane. So the measurement is very precise. Normally, the chord mu is around 0.2 millimeter, and a value of more than 0.4 regarded as abnormal. And when I say abnormal, it means that you should not go for premium lenses or diffractive lenses. However, when you use the Placido's based topographers, the value will be more magnified, so you will find the angle of kappa or the chord mu will be around 0.3, a normal value, and a value of more than 0.6 should be regarded as abnormal. This is very important to know what machine you are using and what principle it uses. If you use the Lens Star or the IOL Master or the Placido's based topographer, so the angle of kappa, or I mean the chord mu, the normal value up to 0.3, and a value of more than 0.6 is regarded as abnormal. However, using the pentacam or the sham float, it is a value of more than 0.4 is regarded as abnormal. The measurement of the chord mu done mainly by the one doctor or scientist, which his name is Chang, two doctors, Chang and Waring, and he published a paper on 2014 named as Monte Carlo simulation based on the ray tracing. The idea that he postulate an eye model replacing the previous and old eye models. The previous and old eye models schematic representation has taken in consideration that the rays of the visual axis and the pupillary axis are all coaxial with the cornea. However, in reality, as you know, because the macula is located temporally, so the visual axis has a little bit, the eye is a little bit tilted or moved in such a way to pick up these rays. So what he did, he simulate a ray trace and tilt it by special angle to simulate or to be coaxial with the visual X. And this rays projects a Purkinje image on the surface of the cornea. And he took the exact center of the iris at the exact center of the pupil at the iris level. And also he exactly take the reflection of this center of the iris on the surface of the cornea. And after establishing the y and x coordinates, he, by special mathematical calculations known as quaternion transformations, he measures the exact distance between the visual X and the pupillary X, which is called the chord mu. This is the chord mu. This is the exact location. This is the one that we are looking for. So, or this schematic model is just to measure this value. So it gives a very precise and accurate measurement of the chord mu at the iris plane. This is the point. So this is when you find this term, because you'll find this term will be repeated, and you might be not understanding what's the meaning of chord mu. A chord mu is a polar representation of the angle of kappa. Is a polar representation of the angle of kappa, and most doctors, they are using this calculation because it is more accurate in measuring the angle of kappa rather than the old traditional way of measurement of angle of kappa. So I like just to speak about this thing so that you will be familiar when you face it in the Pentacam printout. For further understanding the meaning of the chord length or the chord mu and its relation with the angle of kappa, I will go through some principles about the different visual axes or the different axes we have. As you know, we have the optical axe, which is representing the line that passes through the four Purkinje images of the eye. This is the optical axe, which is an imaginary line that divides the eye into two equal halves. So it passes through the four Purkinje images. This is used as a reference axe. This is the optical axe. The other axe we have is the visual axe. And you know, the visual axe is the line that passes from the point of fixation or the object of regard and end up to the fovea. So this is the visual axe, and normally the visual axe will cross a little bit nasal to the optical axe because of the temporal displacement of the macula. The other axe is the pupillary axe, which is the imaginary line that passes through the exact center of the pupil. This line is the imaginary line that passes through the exact center of the pupil. This is called the pupillary axe. After understanding these three important relations or three important axes, it comes the angle of kappa. Now, the angle of kappa is the angle between the visual axe and the pupillary axe. This is the angle of kappa, the angle between the visual axe and the pupillary axe. Now, this angle of kappa, this is an angular representation of the distance between the visual axe and the pupillary axe. However, if we measure this distance in a two-dimensional plane, this is called the chord view. And another important thing, that if we measure the chord view in the anterior surface plane of the cornea, this is a virtual plane. This is called a virtual chord length or the virtual chord mu. I will explain why it is named like this. If we measure the chord mu at the level of the iris or the iris plane, this is called the real chord mu or the chord length. Now, machines that using the Scheimpflug technology or the OCT, they are using the real chord length. However, those who are based on the Placidus based on the reflection of the surface of the cornea, they measure the virtual chord mu.
this should be very well understood. So machines like LensStar and optical biometry and any Placido disk-based topography, when it gives the chord length, it is the virtual one, which is not the real one. Now, the relation between the virtual one and the real one is that the real one, the upper limit of normal is up to 0.2 millimeter, and a value of more than 0.4 is regarded as abnormal. For the virtual one, because of the magnification. Why we say this is virtual? Because the angle of the Kaaba is mainly at the level of the iris, and the reflection of the image made on the surface of the cornea underwent magnification. Because when we look through the slit lamp and look to the cornea, this image that we see in the cornea is magnified by about 0.14%. So this lead to that the image that measured, or the angle measured from the surface of the cornea, is not the real angle of Kaaba. It is virtual, is magnified by about 0.114%. So the normal value of the virtual chord length is the average normal is 0.3, and a value more than 0.6 millimeter is regarded as abnormal. However, the real chord length, mean value is 0.2, and a value more than 0.4 is abnormal. Now, what's the importance of the angle of Kaaba, or the chord length? Is that, as I said before, it is very important in planning for the intraocular lens implantation, especially the premium lenses with diffractive or multifocal IOLs. So the different studies, they found that if the patient has large angle of Kaaba, or in other term, long chord length of the mu, either the virtual or the real one, according to the values that they have given, those people, although they have good visual acuity, but they will have poor visual quality in terms of decreased contrast sensitivity, as well as the high order aberrations and the halos that they will complain. So it is not advised if the chord length the real chord mu more than 0.4 to implant any multifocal lenses, or the toric lenses, or the enhanced depth lenses. Similarly, for the virtual chord mu, if it is measured by a Placido disc-based value of more than 0.6, better not to implant such lenses. So based on this, the thing is that I hope it is clear now the importance of the chord length measurement and its relation with the angle of Kaaba. Now there is some mathematical calculation that's convert the chord length to the angle of Kaaba, that for each 1 millimeter of chord length equivalent to 7.5 degree of angle of Kaaba. Normally the angle of Kaaba is between 2 to 3 degrees. A value more than 3.5 is regarded as abnormal, especially in hypermetropes. And other importance of the angle of Kaaba is also for laser correction. You know, the centration of the laser ablation zone is based on the angle of Kaaba. People with large angle of Kaaba, they will have decentered ablation, and they will have some problem with the post-operative halos and quality of vision, as I said. So this is very important for LASIK surgery, as well as for intraocular lens implantations. I will show on this the exact relation. This is the pupillary center, as you can see here in the center, and the visual axis will cross nasally. And this is the optical axis. Now the angle between the pupillary axis and the visual axis is the angle of Kaaba, and this horizontal two-dimensional distance is known as the chord mu. This is the chord mu. Another thing that I didn't spoke is about the angle of alpha. The angle of alpha is the angle between the visual axis and the optical axis. That's the line, the imaginary line that divides the eye into two equal halves. And in topography, the optical axis is measured by measuring a midpoint in the horizontal white-wide diameters. When we take the horizontal white-wide diameters in the topography, the midpoint is regarded as the optical axis. This angle of alpha also is important in planning for intraocular lens implantation, especially the diffractive multifocal IOLs. So I hope by this diagram and this explanation, it becomes very clear the relation between angle of Kaaba and the chord length.
Another important thing in the holiday report that I would like to emphasize is the meaning of EKR 65. The EKR 65 is measured by the pentacam because the pentacam can measure the anterior and posterior surface of the cornea. So the EKR stands for effective keratometric reading. By effective keratometric reading, it means that it takes the consideration of both the anterior and posterior surface of the cornea, and it gives you the equivalent K reading that is present in a zone of 4.5 millimeter zone. Now, the previous K reading that is taken by all manual keratometries and all the old keratometries based on the anterior surface of the cornea that measures only the K reading of the anterior surface of the cornea, and also take it over a central corneal zone of 3.2 millimeters. That's why for all the previous IOL calculation formulas, you need to have an A constant that compensates for the back surface of the cornea. Now, by the use of the EKR 65, you will not need to use any A constant anymore with any IOL calculation, because already the calculation has taken in consideration the back surface of the cornea that it deducted from the normal, and if any residual value left will be added to the anterior surface of the cornea. That's why it is named as EKR, that's effective keratometric reading. And the 65 stands for that it doesn't take the mean of all values, but it takes 65% of the values. So in a central 4.5 millimeters, there will be around 40,000 points. Anterior and posterior surface of the cornea will be measured, and they will take the 65% value of these 4,000 points and gives you the K reading that represent the whole power in this part of the eye. As you can see here in this the histogram, this histogram represents the distribution of the K reading over the zone of 4.5 millimeters. So you will find that there is a large number present forming a peak here, and a large numbers here. The number ranges from between 46 to around ranges between 43.5 to around 45.5. So if you look to this shape, this is typical shape of the normal cornea. You will find the first peak, which is here, present in this one, which is with the rule astigmatism. So there is steepening here. There is another peak here in the horizontal meridian, and the other powers are distributed all over the cornea. This indicates that large numbers are present in this area, and large numbers are present in these areas. And these numbers, they have taken the 65% percentage. Now, the other chart, which you can see here, is the distribution over the surface of the cornea, the power of the EKR 65. You can see the blue line, this is represent the EKR 65. So as you know, the cornea is a prolate in shape, that's spherical from the center, and becomes flatter as you go toward the periphery. So you can see there is initial increase in the distribution of the powers of the EKR 65 in the initial part over the central 4 millimeter zone. Then it will start drop as you go toward the periphery. The other lines represent the other axial and sagittal map distribution. So the message that I would like to convey to you is that the EKR 65 is very important measurement conveyed or given by the pentacam that replaces the old K reading, and it will make you use any IOL without the need for any A constant, and you can calculate the power of the IOL without the need for any A constants. In this slide, I will show or explain the distribution of the power of the EKR 65 along the optical zone of 4.5 millimeter, and the meaning of the EKR graph, this one, and this is named as the histogram. Now, if you look to the first picture here in the left, which is shows the EKR distribution of a normal cornea. When I say normal cornea, it means a virgin cornea, that it has no any refractive surgery, underwent any refractive surgery. So you can see that the power distribution ranges between 41 to 44 diopter, total 3 diopters over a range of optical zone of 4.5 millimeter. and the histogram shows a peak in the center, which indicate this is the most central point, is the most powerful one in the center of the cornea. So this shows a homogeneous distribution of the power of the cornea over the central 4.5 millimeters. And even in the graph here, you will see that the initial 4.5 millimeter zone, the three dotted lines, the green and the red and the blue which represent the EKR65, and the other red and the green represent the axial map and the sagittal map. So the three lines are coapted or parallel to each other, so that indicate that there is homogeneous distribution of the power over the central 4.5 millimeter. However, after that, because of the prolateness of the cornea, they are getting separated. So this is the normal picture, and this is the normal picture of the histogram distribution of the power of the cornea. Now, in the second slide, this is patient who underwent LASIK procedures. So you can notice that the power range distribution between 36 to 41 diopters. So he has larger range because there is ablation of the central part of the cornea. So he has a wider range of power distribution within the 4.5 millimeters. However, also the initial 4.5 millimeter zone, there is close, the three graphs lines are close to each other. So this is indicate that there is homogeneous distribution of the power. And after this zone, also the lines get separated. So I expect that this patient, he will have good visual acuity, and he has minimal changes in the, as far as the glare or the apparitions that he will face, will be minimal in a zone of 4.5 millimeter. But for example, at night when the pupil get dilated, so he will notice that there is a glare and halos because of the separation of these three lines, and he will complain of spherical aberrations and also reduction in the quality of vision. But however, within the 4.5 millimeter zone, under mesopic conditions, he will be all right. Now, when you look to the third picture here, which is a patient who underwent radial keratotomy, so you notice that the range of power distribution within the center of 4.5 millimeter is huge, around 13 diopters, ranging from 42 to 45 diopters. So it has a very wide range of the power distribution within the central zone, and also the powers are not homogeneously distributed. So even in the, when you look to the graphs, you find that the lines are separated; they are not close to each other up to the 4.5 millimeters. So this patient, he will complain of glare and halos, and the quality of vision of this patient will be not good, and he will be unhappy and unsatisfied patient. Although maybe his visual acuity is good, but he will complain of glare and halos and spherical aberrations and reduction of the quality of the vision. So this is the importance of the this histogram, the histogram graph, and the graph representing the EKR65 over the different maps. And by this, you understand the importance of studying the EKR65. Still in holiday report, as I said, this is the demographic data after has been finished, and this is the middle upper zone I spoke about, and this is the upper right zone. We have left with 6 maps here. Quickly, this maps, the initial one is the topography maps, which shows the axial map and the tangential map. As you know, after we have spoken earlier about the difference between the axial map and the tangential map, the axial map takes in consideration the optical axis, so that it takes the radius of curvature of all the points of the cornea, presuming the eye as spherical in shape. So it gives a general overview of the curvature of the eye. However, the tangential map, it doesn't take in consideration the optical axis, but each point in the cornea has its own tangential reference surface, so that it gives more detail about each point in the curvature of the cornea. So it is more informative and more details given, but it is more noisy. The other section of the report is the bathymetry map, which is the absolute map, which shows the absolute values. And this is the relative bathymetry map. Now, what's the meaning of the relative bathymetry map? It means that the deviation of this map from the normal, how much reduction in percentage of the thickness. For example, there is thickness decrease here by a certain value. Here he will write certain figure. For example, he will write for you 450 microns, but here will write for you 20%.
20% means that there is a 20% reduction than the normal. So the relative pachymetry map is a map that compare the raw data with the normative people. So it is like a deviation map, The other map is the elevation map for the front and back surface map. And I should highlight here that the holiday report, it uses the best fit toric ellipsoid reference surface, so that it will shows the most of areas, as you can see, for irregular corneas will be in a green, because the best fit toric ellipsoid will matches the elevation of that cornea. Any elevations beyond that reference surface will be in hot colors. And of course, this is the front and back surface, and you know the back surface is very important to pick up early ectatic changes. In summary to what we have spoken before, take a home message that the thinnest point of the cornea, usually situated temporally and inferior to the corneal vertex, and if it is more inferior, more than 0.6 millimeter, this is indicate keratoconus or abnormal cornea. The normal range should not exceed than 0.2, but a value of more than 0.6 indicate that this is definite abnormal cornea and most likely keratoconus. Figures between the 2 and the 6 is in the gray zone. That's suspicious, but you should look for any other factors. The other thing that the pupil center is situated temporal to the corneal vertex by about 0.15 millimeter, and it may be superior or inferior. Of course, this is related to the pupillary size, because different pupillary sizes will have different location of the pupillary center. The chord mu that we have spoken, we have the real chord mu, which is measured at the iris plane, and a normal figure of 0.2 and abnormal value of 0.4, and the virtual chord mu, which is measured at the corneal plane by Placidus disc based, a normal value of 0.3 and abnormal value of 0.6. You can see that the figure 0.6 is repeated twice here in the pachymetry, thinnest point, and also in the virtual chord mu. So this is very important figures you should to memorize, so that you can plan your decision regarding intraocular lens implantation, especially the premium lenses or the also for LASIK surgery. Now we will see where we are now. We have finished the curvature maps, we finished the elevation maps, we finished the thickness maps, and the special maps. We finished the holiday report. Now we came across or left with keratoconus progression display. This important display that we are not just only satisfied with the diagnosis of keratoconus, but we want to document, is there a progression or is your patient stable either before or after the cross-linking. So let's go and see what's the keratoconus progression report. Now, before I speak about the Pellin progression display for documenting the ectasia progression, I would like to remind with the latest definition of ectasia progression. Now, the latest definition of ectasia progression is when you have a consistent changes in at least 2 of these variables. We have very important 3 variables, that is steepening of the anterior corneal surface, and or steepening of the posterior corneal surface, and or thinning of the posterior thinning of the cornea, or changes in the thickness profile from the periphery toward the thinnest point of the cornea. Now, these 3 important variables, 2 of which, if there is a consistent changes in 2 of these variables, is enough to document the presence of progression in the ectasia. I think this is similar to, for example, in glaucoma. When you have glaucoma, you have to diagnose glaucoma, you have to document the presence of at least 2 variables like corneal, like cupping and visual field, and intraocular pressure changes. So if you find 2 of them is enough to diagnose glaucoma. Here to diagnose progression of ectasia, you have to have 2 variables at least to document ectasia, and this is of course should be done beyond
the magnitude of the noise of the test. The noise of the test is this is called statistical noise analysis. Noise means that some of the data taken maybe they have a large rate of fluctuation beyond the normal, and this fluctuation is not because of the observed data, but it is due to an errors or bias made by the machine, or made by the doctor himself, or made by the sampling itself. So by special statistical analysis, they can remove this background noise, so that the observed data will be in a solid background, document that there is a progression in the case. By understanding the definition of documentation of the progression of keratoconus or keratoptasia, the ABCD classifications came to fulfill all the requirements and the prerequisites needed to document the progression of ectasia. By documenting the changes that happens on each layer of the cornea. For example, the A stands for the changes that happens over the anterior radius curvature, over the 3 mm zone, over the thinnest point. And the B stands for the changes in the back surface of the cornea, that's the radius of curvature over a 3 mm zone on the thinnest point. Similarly, the C stands for the corneal thickness over the thinnest point of the cornea, not the apical as seen in the previous classification. And the last one is the D, which stands for the distant visual acuity. That's usually manually placed by the doctor himself by putting the distant visual acuity in the software. Now, the ABCD classification addresses all the queries and the problems that faces doctors on the previous classification, which is the Amsler-Kromak classification, because that classification was mainly based on the keratometry and the apical pachymetry. So it is mainly dependent on the changes that happens on the anterior surface of the cornea, not taking into account the changes that happens in the posterior surface of the cornea. So this was not enough and not satisfying for the doctors. So by assuming the ABCD classification, it covers all the aspects of documentation of the keratoptasia progression. And this classification has been placed in the Pentacam software. This is the latest ABCD classification or staging system. It starts from stage 0. This is a new addition or upgrade in the classification, because previously there was no 0 stage. And this stage 0 doesn't mean that the patient is normal, but he has early keratometric changes of keratoconus, but this is given stage 0. And it continue up to the stage 4. So we have 5 stages, and each stage has a specific changes in the A and B and C and D. So this is the new Pellin ABCD classification or staging or grading system. Now this classification you will find in the software of the Pentacam displayed as this display. And each one, A, B, C, D, you will notice the changes in each layer of the cornea, that one, what happens. And this is the final staging system of the patient. So when you say A0, it means that he has a very minimal changes on the anterior surface of the cornea. B4 means advanced changes in the posterior surface of the cornea. C3 is a moderate changes in the thickness of the cornea, and D0 it means that he has a good visual acuity, of course, because minimum changes in the anterior surface of the cornea, so the visual acuity is good. This type of staging or classification is useful in population-based studies in which you want to classify a group of people, what are the stages that they have as far as keratoconus. But this mode of presentation of the data is not useful to document personal progression in a particular patient. So this differs than the progression analysis. So this is a staging or classification, but not documenting the progression. For the progression, we have another tabular or another horizontal bars that I will show in the next slides. that documents the progression of the case, so that you know whether your patient is stable or not. So this is the staging system of classification is useful in a population-based studies, but not useful in documenting progression in a personal case. Now, after we spoke about the ABCD staging and classification, now we come to the main bulk of the progression analysis, known as the ABCD graphic progression analysis display. And this graphic display represented in horizontal bars, and each part of the staging, that's the ABCD, is represented, so that we document the changes in each layer of the cornea. For example, A stands for the radius of curvature of the anterior surface of the cornea, and B for the back surface of the cornea, and C for the thickness, and D for the distant visual acuity, which is manually placed by the doctor and not generated by the machine itself. Now, these horizontal bars, as you can see, 5 or 6 bars here, each bar represent a visit of the patient. For example, this is the baseline visit. This is, for example, after a 6-month visit. This is after 1 year, and so on. So that we can compare the different visits and see what happens to the patient as far each part of the staging system. This is very useful in documenting the progression and the staging of the progression of the ectasia, unlike the independent of the Kmax or pure changes in the anterior surface, because the Kmax is very poor predictor as well as effective parameter to document progression, because to document the changes in the Kmax, you need to have a significant changes in the anterior surface of the cornea. By that time, the patient will have an advanced disease. So Kmax is not a good predictor of the progression. We shouldn't depend on the Kmax, but the ABCD progression analysis shows very useful result in early documentation of the progression. Another thing is that the ABCD progression display has made by doing a study on 2 groups, keratoconus groups and normal group. The normal group, they have the green color, and the keratoconus group has the red color. And the result interpreted within a confidence interval between 80 to 95%. Now the green dotted here is the 95%, 80% confidence interval, and the solid green is the 95% confidence interval. Similarly here, the red dotted is the 85% confidence, and the solid red is the 95% confidence interval. Of course, this is also has taken in consideration the removal of the background noise made by the fluctuation of the tests due to any bias from the sampling, or bias from the doctors, or bias from the machine itself. So the study done taking in consideration to remove the background noise, so that you have a reliable information for documenting the progression analysis. Another thing that the progression analysis should be taken in consideration other variables like the age of the patient. Now, any mild changes, even mild changes in a young patient as compared to a normal population should be taken seriously, because there might be a rapid progression in in his ectasia, and the risk of weight will be very high. Unlike if we take the same progression or the changes in the cornea in an old patient, now that patient, the risk of weight is less. So although the same changes happens between as far as the anterior surface or posterior surface of the cornea, however, the age variable now differs and need to take an urgent action based on his age. Also, other parameters include the bad display that we have explained before. That you should take in consideration the changes that happens in the bad display. Although bad display is not useful in documenting the progression, but it should be taken in consideration. Here is also another tabulation for the other risk indices or ectasia indices that is used for following the keratoconus, based mainly on the anterior surface of the cornea. This is from the previous classification, also has been placed here. But this is the mainstay and the main bulk of understanding. For example, if you see here, one of these visits, he has a marked increase in the decrease in the thickness of the cornea. So this is indicate that this patient crossed the red flag here. So he's at risk of severe thinning of the cornea. Similarly, here in this visit, he has increase in the curvature of the posterior surface of the cornea, and he has crossed the red flag. So like this patient, the doctor should decide when to interfere to arrest the disease based on his age, based on the thickness of the cornea, whether he will do a cross-linking or do intracorneal rings. This is depends on the the doctor's opinion. Now we reach to the completion of the first session of this lecture about the topography, aberrometry, biomechanics, and more. Now the next session will be about understanding the corneal aberrometry. I hope that you have benefited from the previous slides, and I hope I will meet you in the next session regarding understanding aberrometry. Now the links are in front of you for those who want to revise anything, or if you have any comments, you can write to me. Thank you very much.